Greetings of virtue and respect. Good morning, ladies and gentlemen. Allow me to cordially welcome and greet our respectable excellencies. We have Mr. Justinus Kristianto Widiwardono, Deputy Chairman for National Measurement Standards and also Acting Chairman of BSN. Good morning, Mr. Chris. We have Mrs. Oichai Ongrai, Chair of Asia Pacific Meteorology Program, Energy Efficiency Focus Group. Good morning, Mrs. Oichai. Mr. Hendra Iswahyudi, Director of Energy Conservation, Ministry of Energy and Mineral Resources, Republic of Indonesia. Mr. Xiong Li Min, Chief Meteorologist and Head of Optical Communication Laboratory, National Institute of Meteorology, China. Good morning. Mr. Gufron Zaid, Director for System and Harmonization of Accreditation and Acting Director of National Measurement Standards for Thermoelectricity and Chemistry of BSN. Good morning, Mr. Gufron. Mrs. Dias Tiarini, Director of National Measurement Standards for Mechanics, Radiation, and Biology of BSN. Good morning, Mrs. Dia. And also, I would like to greet all of BSN's official, esteemed speakers, representative from APMP, members EEFG, distinguished guests, and all participants that join us today either in person or through online. A very warm welcome to all of you. Apologized for the delay of the event. On behalf of BSN, especially to the Deputy SNSU, and also the Asia Pacific Meteorology Program, Energy Efficiency Focus Group, it is a great honor to welcome you all to the APMP-EEFG International Symposium 2025. This symposium held under the theme Strengthening Collaboration for Quality of Sustainable Energy. And the symposium is part of a series of activities conducted under the APMP-EEFG and Indonesia's National Quality Month or Bulan Mutu Nasional. These activities taking place on 28 to 30 October 2025 in Tangerang Selatan, Banten, and these activities reflect our shared commitment to promote quality and sustainability through meteorology. Before we begin the symposium, allow me to introduce myself. My name is Reza Aditya, and I have the honor to be your Master of Ceremony for today. And also, before we continue, I would like to express our sincere appreciation to our sponsors, ASIC Instruments Pte Ltd, PT Sukovindo Persero, and PT Gencraft Labs. Please give a round of applause for our sponsors. And now, to start the symposium, ladies and gentlemen, I kindly invite everyone to rise as we sing the national anthem of Indonesia, Indonesia Raya. Ladies and gentlemen, please be rise. Ladies and gentlemen, please be seated. To bless this meaningful event, let us take a moment to offer our prayers. I kindly invite Mr. Arif Muhammad Fadli from SNSU-BSN to lead the prayer recitation. To Mr. Fadli, the stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. Peace and blessing of Allah be upon of you. Ladies and gentlemen, before we begin our session, let us take a brief moment to reflect and seek blessing for the success of this gathering. In this seminar, where experts and colleagues from across the Asia Pacific have come together to share knowledge and ideas for a more sustainable and energy-efficient future. It is fitting that we pause to offer our prayer. I will now recite a short prayer in the Islamic tradition. For our friend and colleague from different faith and belief, you are most welcome to join this moment to reflection and offer your own silent prayer according to your respective tradition for peace, wisdom, and the success of our collective effort. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala asrofil anbiya'i wa mursalin Sayyidina Muhammadin wa ala alihi wa sahbihi ajmain. Oh Allah, the source of all knowledge and wisdom, we gather here seeking guidance and understanding to serve humanity through science and integrity. Bless our discussion and effort in this seminar, that our work in meteorology might bring precision, fairness, and benefit to all nations. Grant us the wisdom to use the earth resource responsibly to advance energy efficiency and renewable energy for a sustainable future. Protect us from arrogance and ignorance, and inspire cooperation, honesty, and compassion among us. Oh Allah, make our knowledge a light that leads to goodness, not a tool of harm or injustice. Help us to fulfill our duty as steward of the earth, to build a future of balance, prosperity, and peace for all your creation. Rabbana taqabbal minna innaka antas samiul alim wa tub alaina innaka antat tawwabur rahim. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu alaihi sayyidina Muhammad wa ala alihi sayyidina Muhammad wa ala alihi wa sahbihi ajmain. Walhamdulillahi rabbil alamin. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Fadli, for the prayer recitation. Ladies and gentlemen, like as we know, this event brings together experts, researchers, policymakers, and industry practitioners to exchange ideas and strengthen collaboration and advance innovation in energy efficiency. To officially open today's symposium, I am honored to invite Mr. Justinus Kristianto Widiwardono, Deputy of SNSU-BSN and Acting Chairman of BSN, to deliver the welcoming speech. Please welcome to the stage with a round of applause, Mr. Justinus Kristianto Widiwardono.
Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua, Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, and good morning to all participants in this international symposium. Our distinguished guest, Dr. Oijai Ongrai, the Chair of the Energy Efficiency Focus Group, Asia Pacific Meteorology Program, or APMP, and Bapak Hendra Iswahyudi, the Director of Energy Conservation from the Ministry of Energy and Mineral Resources, and also Professor Xiong Limin, Chief Meteorologist and Head of Optical Communication Laboratory, the National Institute of Meteorology, China, and also all the speakers who will give us insight of the energy efficiency during the next sessions. Representative from the APMP, members of the Energy Efficiency Focus Group, my colleagues from industry, from the laboratories, and also all participants, distinguished guests, ladies and gentlemen. First of all, for my colleagues from APMP, welcome to Indonesia. Thank you for coming here. I hope you can enjoy the atmosphere of local environment during your visit. And also I would like to welcome all of you to this International Symposium on Energy Efficiency 2025 under the theme Strengthening Collaboration for Quality of Sustainable Energy. This symposium is a joint activity between the APMP Energy Efficiency Focus Group and the Indonesia National Quality Month, or Bulan Mutu Nasional, or BMN. As already mentioned by our Master of Ceremony, the APMP-EEFG program comprises this symposium, followed by technical visit to PV industry and laboratory, and then another EFG meeting in the next couple of days. Whereas for the BMN series consists of this symposium, followed by scientific presentations on calibration, instrumentation, and metrology, as well as some metrology workshops. These joint activities reflect our shared commitment to promote quality and sustainability through metrology, because we believe that metrology plays an important role in these efforts. We hope these events can bring together experts, researchers, policymakers, industry practitioners to share knowledge and experience, to exchange ideas, and strengthen collaboration in energy efficiency. While BMN promotes the importance of quality across industries, products, and services, the EFG activities focus on quality in energy measurements, which plays a fundamental role in ensuring sustainability, efficiency, and innovation. The message is clear: the quality and sustainability must go hand in hand to support the nation's transition toward a green economy and a resilient future. Distinguished guests, ladies and gentlemen, at the heart of these initiatives lies one of the most critical global challenges of our time: achieving net zero emission. This concept, often referred to zero carbon emission, will represent the balance of the amount carbon released into atmosphere and the equal amount of carbon absorbed by the Earth's natural systems. And in 2015, we remember that 200 countries signed the Paris Agreement, committing to reduce the greenhouse gas emission and limit global temperature rise. To realize this goal, Indonesia continues to advance its energy transition, developing renewable energy infrastructure and reducing our dependence on fossil fuels. However, this transformation requires accurate and reliable measurements to ensure the quality, efficiency, and safety of a renewable energy system. So in this regard, the National Meteorology Institutes from all economies, including SNSU-BSN, together play vital roles in ensuring the validity and international equivalence of all measurement results through the process of value dissemination and traceability. This ensures that data used in research, manufacturing, and energy development are globally comparable and trustworthy. In Asia Pacific region, SNSU-BSN is an active member of APMP, a regional organization that unites NMIs across the Asia Pacific region that promotes scientific cooperation, capacity building, and harmonization of measurement standards. And within the APMP, the EEFG serves as a dedicated forum to advance metrology in the field of energy efficiency and sustainability. Before closing, allow me to extend our heartfelt appreciation to all of our distinguished speakers who will share their invaluable insights and expertise. Your contributions will undoubtedly enrich our discussion and inspire new partnerships. We also express our sincere gratitude to all participants, partners, and especially sponsors for their support and dedication. Your presence and engagement demonstrates our shared vision of advancing meteorology, strengthening regional cooperation, and achieving sustainable energy for all. And let us make this symposium not merely a forum for dialogue, but a catalyst for action, where knowledge drives innovation and collaboration leads to real-world impact. And together, we can build a future where energy is clean, accessible, and of assured quality. And with that, I would like to officially declare this International Symposium of Energy Efficiency 2025 open. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om. Thank you.
Thank you, Mr. Chris, for your inspiring welcoming remarks. Ladies and gentlemen, next it is my pleasure to welcome Mrs. Oichai Ongre, Chair of APMP-EEFG, to deliver the opening remarks. Please welcome to the stage with a round of applause, Mrs. Oichai Ongre.
Selamat pagi. Good morning, distinguished guests, ladies and gentlemen. It is my great honor to represent the Asia Pacific Meteorology Program and the Energy Efficiency Focus Group, APMP-EEFG, at this important event. First of all, I would like to express my heartfelt appreciation to Mr. Cristiano, Deputy of SNSU-BSN, for his kind and inspiring the opening address. And the entire organizing committee of SNSU-BSN, led by Mr. Helmi Saini and his organization team, project overseer, for their excellent preparation and warm hospitality and hosting this international workshop. The theme of this symposium, the strengthening collaboration for quality of sustainable energy, reflect both the national vision of Indonesia and the regional mission of APMP. Across our Asia-Pacific region, we are witnessing the rapid transformation towards renewable, efficient, and low-carbon energy system. However, behind every successful energy transition lies on one essential foundation: measurement you can trust. Whether it is the performance of solar PV panel, the efficiencies of new energy, EV charging station, or the reliability of smart grid, accurate and traceable measurement is vital for innovation, international energy trading, and also public confidence. This symposium clearly demonstrates that the collaboration by bringing together experts from China, Korea, Australia, Indonesia, and Thailand, together with the researchers and industrial partners, this can support the evidence-based policy and to accelerate the adoption of clean energy technologies with confidence in their quality and performance. Distinguished guests, participants, today's opening marks not only the start of technical program, but also renew the commitment to scientific partnership for sustainable energy development. Let us use this day to exchange the knowledge, share experience, and build enduring cooperation for benefit of our regions and our future energy. On behalf of the APMP Energy Efficiency Focus Group, I wish you all successful and have a productive workshop, symposium, and event throughout these 3 days. Terima kasih banyak. Thank you very much. ขอบคุณค่ะ
Thank you, Mrs. Oichai, for your kind words and continued support. Ladies and gentlemen, now we will begin the keynote session. The first keynote speech will be given by Mr. Hendra Iswahyudi. He joining us through the Zoom meeting today. He is the Director of Energy Conservation, Ministry of Energy and Mineral Resources, Republic of Indonesia. Let me read a little CV about him. Mr. Hendra received bachelor degree in physical engineering from ITS Surabaya. He received master degree in planning and public policy, from University of Indonesia. Also postgraduate in economics from University of Indonesia. To Mr. Hendra, the stage is yours.
Okay, thank you. Ladies and gentlemen, good morning, distinguished guests, colleagues, and friends. Allow me first to extend my warm greetings and deep appreciation to Mr. Kristianto Widiwardono, Deputy for National Measurement Standards, BSN, and Dr. Oichai Ongrai, Chair of the Energy Efficiency Focus Group under the Asia Pacific Meteorology Program. I also wish to acknowledge the representatives from government agencies, academia, industries, and associations who have gathered here this morning. It's a pleasure and an honor to be among a community that shares the same passions for advancing the quality, reliability, and inclusiveness of sustainable energy system. I would also like to commend BSN and APMP for organizing this important forum, which bridges science, policy, and industry, three aspects that must work hand in hand to realize a clean energy future. The energy transition in Indonesia plays a critical role in our national vision for self-reliance and resiliency. Under the Astachita vision, energy security and independence are defined as one of the key pillars of Indonesia long-term development. Through Presidential Decree Number 1 of 2025, the government established a task force for accelerate national energy security and downstreaming effort. This vision aligns with global expectation following the global stocktake at COP28, which calls for the world to triple renewable energy capacity and double the rate of energy efficiency improvement by 2030. Indonesia is committed to contributing to that global movement, achieving net zero emission by 2060, with a peak in emission of energy targeted around 2035. For this reason, Indonesia has made commitment to mitigate the climate risk by setting up our enhanced nationally determined contribution to reduce 31.9% of our emission by 2030. Based on our enhanced nationally determined contribution, the energy sector must mitigate 358 million tons of CO2 by 2030. Energy efficiency and renewable energy becomes most critical strategies, potentially contributing to mitigating around 37 and 51 of the total emission. Since 2019, our annual emission target have been achieved, and as of September 2025, it already indicates strong compliance to this year's target. 165 million tons of CO2 equivalent, about 46% of the NDC target. Indonesia is blessed with abundant renewable energy resources across 38 provinces and more than 17,000 islands. We have identified around 3.7 gigawatt of renewable potential, dominated by solar power at 3.2 gigawatt, 3,294 gigawatt, followed by hydro, wind, geothermal, bioenergy, and ocean energy. However, we have only utilized around 0.4% of that potential. This gap represents both a challenge and an opportunity to accelerate deployment through better infrastructure, policies, and standards. The Indonesian government is currently preparing a net zero emission roadmap for energy sector. Based on the roadmap, around 95% of carbon emission from the business as usual scenario will be mitigated by 2060, leaving around 129 million tons of CO2. By 2060, Indonesia will rely on 443 gigawatt of power capacity, where 42% will come from variable renewable, such as solar and wind, supported by 34 gigawatts of storage and a national supergrid. Our transition strategy confides 6 main pillars: energy efficiency, electrification, coal phase down, renewable development, new energy sources, including hydrogen and nuclear, and also CCS, CCUS technologies. This transformation requires around $1.09 trillion in cumulative investment, or roughly $13 billion per year across generation, transmission, and also storage. To decarbonize the supply sector, Indonesia is developing a supergrid that connect renewable rich island with major demand center. By 2030, we project strong demand for minerals and batteries, driven by electric vehicle and renewable energy storage system. This transition will also stimulate new industries, from battery manufacturing to smart grid development and digital control system. As of September 2025, Indonesia's total installed power capacity reached 107 gigawatt. Renewable now account for 15.4 gigawatt, or roughly 14% of the total capacity, led by hydropower, geothermal, and also bioenergy. In 2025 alone, we added 1.1 gigawatt of new renewable capacity, a clear signal that the transition is gaining momentum. Continued regulatory reform, financing, innovation, and stakeholder collaboration. One of our greatest achievements is ensuring that almost all Indonesians now have access to electricity. Our electrification ratio stands at 99.83%, and our rural electrification ratio is already 99.94%. Through the Rural Electrification Program, we are expanding medium and low voltage network, adding more than 16,000 kilometers of lines and also 720,000 new customers by 2029. This program demonstrates that energy transition and energy equity must go hand in hand. Over the years, Indonesia's renewable energy share in the national mix has increasing significantly from 10.9% in 2022 to 19.5% in 2025, with strong growth from hydropower, geothermal, bioenergy, and also solar. We are confident that with continuous reform and investment, we can meet and even exceed our national target by 2030. To accelerate the transition, we are focusing on quick wins and emerging opportunities. This includes improving investment framework, streamlining permit, and promoting innovation. We are strengthening energy efficiency, low carbon technologies, and smart electrification. We are also developing carbon trading, green finance, and also energy saving insurance to reduce investment risk. Together, this initiative build confidence and unlock the full potential of renewable energy deployment. Distinguished participants, ladies and gentlemen, in the coming decade, Indonesia plans to add over 42 gigawatt of renewable power and storage system. This expansion could generate 700 7,000 almost 7,000 green jobs and reduce emission more than 129 million tons of CO2 by 2034. To support this, the government provide various investment facilities, including tax holidays, import duty exemptions, and also biofuel incentive. We also encourage public-private partnership and joint venture to mobilize capital efficiency. By ensuring attractive costs and transparent incentive, we make renewable projects both profitable and sustainable. Policy reform remains the backbone of our strategy. Through presidential regulation 112 in year 2022, we introduced a transparent pricing mechanism for renewable. Through the implementation of Ministry of Energy and Mineral Resources Regulation number 10 in year 2025 defines the energy transition pathway in the power sector. It covers different strategies to accelerate the transition, emphasizing the development timeline for renewable energy diversification technologies such as biomass, clean hydrogen, and ammonia, as well as nuclear power plant. It also amplifies innovation such as retrofitting coal-fired power plants with CCS and smart grid to support the reliability. Moreover, some additional regulation complement this framework. The first is regulation promote local content where it supposed to the bottlenecking the renewable energy investment, and also regulation to standardize PPAs and in renewable energy power purchase. Together, this reform provide clarity for investors, developers, and local industries to move confidently toward clean energy. In conclusion, the recap of new Ministry of Energy and Mineral Resources policies are expected to provide strong regulatory framework for the new renewable energy and energy conservation development. In 2025, there are 5 ministerial regulations established in place, including particularly the guideline for power purchase agreement for renewable energy, number 5, and the energy transition for electrification sector, number 10. Some other regulation in process also being prepared. To advance decarbonization, Indonesia has launched its power sector carbon trading, known as PT-BEE-PU. It currently includes 246 million emissions unit registered in the national registry, covering both coal and gas power plants connected to PLN grid. Alongside this, we have introduced the Renewable Energy Certificate Program, which allows industries and companies to voluntarily purchase and claim renewable electricity. The system not only meets consumer demand for green energy, but also creates new revenue streams for renewable power provision. The energy transition is also a job creation opportunity. From geothermal to solar, from hydro to energy storage, Indonesia renewable program are projected to generate over 700,000 green jobs by 2034. Our guiding principle is simple: no one should be left behind. The success of the energy transition as depends on collaboration among all sectors. State-owned enterprises and private companies drive innovation and investment, and institutions like BSN and APMP ensure the quality, measurement, and credibility of this entire ecosystem. Together, we can ensure that Indonesia's energy transition is fast, measurable, and just. Thank you again for your engagement and collaboration. I look forward to the fruitful discussion.
Thank you, Mr. Hendra, for the keynote speech. Ladies and gentlemen, next we will listen the keynote speech from Mr. Xiong Limin, Chief Meteorologist and Head of Optical Communication Laboratory, National Institute of Meteorology, China. Please welcome to the stage with round of applause, Mr. Xiong Limin.
Can you give me the, how can I play my presentation? Yeah. Well, okay. Yeah. But where is my presentation? Oh, yeah, wait. Hello, everyone. My name is Xiong Limin from NIM of China. And today my present topic is metrical traceability system and the new development in photovoltaic field. Yeah. Okay. Which? Okay. The presentation has three parts. One is metrical traceability system of NIM for PV field. As we know, in PV industry, power, watt, is the center of, I cannot see, attention. Power is the amount of energy consumed per unit time. Okay, too small. And in power journal of PV power station and the power of PV modules and power of solar cell piece. This means optical power. The sun provides the power to human. We often use standard solar irradiance, 1,000 watt per square meter. So how is the watt in the PV field and how measured it in the laboratory? We must establish the relationship between output signal and the power. According IEC 609044, it established calibration procedures and requirements for PV traceability. NIM already built the standard from the SI unit to the factory. Mm-hmm. Mm-hmm. Okay. From 1990, NIM built comprehensive PV metrological capability ranging from traceability to SI unit. The first one is cryogenic radiometer system. And the last is how to calibrate at the outdoor for PV journal station. First, we built relationship between trace detector output current and optical power. It's from cryogenic radiometer to chip detector. We built cryogenic radiometer reference measuring units. This cryogenic radiometer is a relation detecting system that operates at the U-channel temperature. And it used the electrical substitution method to measure the absolute radiant power with the relative uncertainty of radiant power measurement, reaching up to 1/10,000. This figure shows how we use this. We can measure the mechanical outgoing light with cryogenic. Then we change the position with the trap detector. We can get trap detector's responsivity. This shows how we built the relationship between standard detector output current and optical power, from trap detector to standard detector. We know the spectral responsivity of standard detector because in different wavelengths of light, the solar cell have different responsivity. So we must measure its spectral responsivity curve. At first, we must build the insistence. Through the monochrometer, we can change the white light to the different color light to the detector. Because we know the spectral responsivity of trap detector, so through the signal of the trap detector, we can know the watt of the light. And when we change the standard detector to the same position and measure its signal, so we also can get the responsivity of the standard detector. So NIM have the standard measuring unit for spectral responsivity is our uncertainty now. Next time, we must build the relationship between reference solar cell output current and irradiance. How we can get the value from the standard detector. Short circuit current is very important because we can, through it, then I can know the irradiance of the solar simulate. Through this equation, and we know the CV value, yes. So if we can measure the spectral responsivity of the solar cell, and through the AM1.5 global spectral distribution of the solar irradiance, we can get the CV value. We can through this instrument, and yes, we can get this value. CV value means short set current of the reference solar cell on the 25 degree and with AM1.5 globe spectral conditions and the irradiance of spectral constant. Through this one, if the light irradiates to the solar cell, when the signal of the solar cell equal to CV value, we can think the irradiance is 1,000 watt per square meter. Use this instrument, we can test the light power through the standard detector as the above. And we can remove the solar cell at the same position on the platform. And also we can measure its irradiation uniformity and control the temperature. Also, we need DC bias light. Sorry. We can get the CV value with this instrument. Also, we also attend some international comparison of reference solar cell with AIST of Japan, with Europe by PDB, and we also do calibration with NIST. This is very important because in factory we need not to know the solar cells CV value, but we need to know PV module's power. So we built a relationship between PV module output current and optical power. How we can trace it from reference solar cell to PV module. We consider memory factory like ISC is the CV value. And we also need to know spectral mismatch of the solar simulator. Also, we need to know inconsistency between reference solar cell and the PV module. And we must know the non-uniformity of PV modules irradiance. And insistability. Also, we need to know temperature and position of voltage, current, and power measurement. We also need the PV module's position. We also need to know the contact resistance, and the module capacitance, and repeatability. Also, we built the instance about calibration of solar cell pieces. We also need know, we must need know STC condition. It means the irradiance is 1,000 watt per square meter. And the spectral distribution must near to the standard sound. Yes, AM 1.5 G. And also we need to control the temperature to 25 degrees. In this condition, we can calibrate the solar cell pieces. Also, some instruments need NIM of China to calibrate. How to calibrate light with cell radiometer? Because the cell radiometer is made by the solar cell, so it's the spectral responsivity is not flat. It's just like that one. It's curve. In China, we used two-lamp solar simulator, and its spectral distribution is very, very near to the standard sun. And we use this solar simulator can calibrate the radiometer. Its uncertainty less than 1%. Like this one. We should measure the spectrum of the solar simulator. And we use the standard solar cell to calibrate the light irradiance. And we use laser to get the position. And we change the cell radiometer at the same position, so we can measure its sensitivity. Many people use pyranometer in the outdoor. So NIM of China also provide calibration about it. We also use the solar simulator. But you know, because pyranometer is not the photoelectrical, it's used the thermal, we can say hot. So we don't need know its spectral responsiveness. We must use the absolute radiometer to calibrate the light irradiance. And after this, we can replace the tested pyranometer into the same position. We can get its wattage signal. Okay. The above is introduced traceability of NIM, but except that we also have some advantage and new methodological technical development in photovoltaic field of NIM. First, we have 13 years experience and measured the PV module. So we consider so many factors to measure it more accurately. Now we consider the high capability efficiency effects of new technology, because you know TOPCon, HJT, and XBC have a higher capacitive. Also, we consider stability lines of meta-step PV modules with low irradiance. We also consider the EL image of the PV module. Now we also do some work for the recovery curve after UV 120 hours. We also have some work to metrology capability for perovskite and perovskite tandem PV cell and the modules. We use the step solar cell, solar simulator. We also do some work for spacecraft, solar area, and the cell power measures, such as in the moon move. I don't know, that May, yes, we calibrate its solar cell. We also measured the IV curve of the area, solar cell area in the near space for the major project. Now we do some work to the more calculator about the pyrometer, because it have so many calculators, include angle, linear, and temperature coefficient. Now we do some work about this. And today we do some work for the factory, because you know it's not enough the factory get a standard PV module. They need to know how to use it to measure the tested PV module online. So we developed some document to help them to match it more accurately. In the future, we have the application signals from PV cell, PV module, production line, PV power station, and we hope we can do some work overseas trade. Last one is the testing developed in PV field of NEEM. NEEM's target in the PV field lead the industry, supporting the industry, and regulate the industry. So in NEEM, we also do some work about the PV voltaic test process. We, according to IEC 61215-6, there are the standards. We built the testing capability of PV laboratory in Suzhou, not in NEEM. Our base is in Beijing, but we built the PV laboratory in Suzhou. They have some work need to do for the collaboration in the PV laboratory, such as for the solar simulator, we must know it must class 3A. Now it's 3A plus. We also do some work to the UV chamber and light soaking chamber and parallel meter. The important work in my testing laboratory is maximum power determination. This year and 2025, more than 2,000 pieces of PV module are calibrated in Suzhou PV laboratory of NEEM. Also, we built the calibration of the relative spectral responsivity test for PV module. We also do hotspot irradiance test and the UV test, thermocycling test, and damp heat test. I think in Indonesia, this test is very important. We also do static and dynamic metrical load test We also do the other test. Okay, our publicity and training. Every day, NIM, we hold the training class to learn in NIM and from the industry, from the institute. We teach them how to measure the PV module and the other things. In 2024 and 25, we hold the PV knowledge training course for Mekong countries. We achieved good. And today I see my friend from Thailand, Bong, is also here. In 2026, we have the international training program, and maybe next year, April, we will hold the more than 20 developing countries, and this is supported by Chinese government, and they will provide some fund to do this. If any interested person can, if you want, you can contact my colleague for detail. This their email. Okay, thank you. Thank you.
Thank you, Mr. Xiang Limin. I'm sorry, Mr. Xiang Limin. Could you please to stay on the stage because we will start to give the token of appreciation. So yeah. So if there's any question from a participant, do you want to ask to Mr. Xiang Limin first? Okay, so if there's no question to Mr. Xiang Limin, thank you very much. So now I would like to invite to the stage, please stay at the stage, Mr. I would like to invite to the stage Mr. Chris Tianto to give the token of appreciation to Mr. Xiang Limin. Mr. Chris will give you a token of appreciation, Mr. Xiang Limin. Sorry, let me help you with your microphone. Sorry. Okay. Ya, sini Pak. Okay. Please give a round of applause for Mr. Xiang Limin, everyone. Okay, please stay on the stage, Mr. Chris. Okay, one more time to taking pictures, okay? Okay, thank you. Please stay on the stage, Mr. Chris, and also, okay, there's one more, sorry. Okay. All right, thank you. And now I would like to invite all of our speakers to join us on the stage to taking a group photos, and also Mrs. Oichai, and also all of those speakers for session 1 and also session 2. Please join us on the stage. We will take a group photos. And also Mr. Adit, please join us on the stage. We will take a pictures on the stage. Oh, Mr. Xiang, okay. I would like to invite you back to take pictures on the stage with all of the speakers. Okay. So we will take like a couple of pictures. Okay, first photos. Okay, 1, 2, cheers. Okay, is there any specific sign that we want to take in the pictures? I mean, like if not, we maybe can have our hand together like this. Okay, yep, like this. And then face to the camera. Okay, everyone's ready. 1, 2, cheers. Okay. Okay, is it good? Thank you, thank you. You may be seated. So now I would like to invite all participants to please be rise. We're going to take pictures together. So this time the photographer will come to the stage and then we're going to take pictures together. All participants, ladies and gentlemen, please be rise. So we can take pictures together. Okay. All right. Okay. Okay. My colleague here will take pictures of all of us who joining the symposium today. Is it? Okay, ready? 1, 2, cheers. Okay, one more time. Maybe we can have our fists together like this. Okay, to show our spirits on today's event. All right. Is it good? Good. Okay, thank you everyone. Please be seated. So ladies and gentlemen, before we continue to the first session of today's technical discussion, now we will take a short break for about 15 minutes. Please enjoy the refreshments and we will resume shortly. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Yeah, ladies and gentlemen, you can enjoy the refreshment that already prepared outside of the room. And then we will back 15 minutes, yep, after the short break. Thank you.
Kehidupan masyarakat dunia di era peralihan masih menggunakan peralatan sederhana dalam kesehariannya. Ilmu pengukuran atau metrologi sudah dikenal sejak zaman dahulu dengan menggunakan metode pengukuran sederhana dan menetapkan standar yang digunakan untuk memudahkan proses produksi barang, pembangunan infrastruktur, hingga memperlancar transaksi perdagangan. Revolusi industri yang berawal di Eropa membuat ilmu pengukuran terus dikembangkan oleh para ilmuwan.
ASEC Group is a one-house solution provider for all your instrumentation and calibration needs. At ASEC Group, we understand that precise measurements are essential and critical for your business long-term success and sustainability. That's why we bring a comprehensive range of products and services covering diverse measurement and control aspects, including temperature, humidity, pressure, flow, level, air quality, and more. We have two distinct business units, ASEC Instruments and Isolab Singapore, each with a different focus. Our business operates through three well-established in-house brands to cater to different customer segments and applications. ASEC Sensing is our brand of custom-made high-accuracy temperature sensors, including green building applications, explosion-proof sensors, and thermowells to comply with industry standards and certifications. Blue Gizmo is our dedicated brand with a range of portable instrument and data acquisition systems trusted in food, HVAC, cold chain, and warehousing industries. Taisho focuses on process and control instrumentation with precision sensors that can be integrated with various systems. Isotech. We also provide calibration and testing services through our sister company, ISOLAB Singapore. ISOLAB is an ISO IEC 17025 accredited laboratory with dedicated expertise in calibrating a wide range of instruments, including temperature, humidity, pressure, electrical, stopwatches, timers, airflow, and sound level. ISOLAB can perform on-site calibration and temperature mapping for mega warehouse sizes, cold chain storage, and transportation facilities. Our in-house calibration capabilities at ISOLAB are actively upgraded to calibrate standard PRTs using ITS 90 fixed points. ISOLAB's capabilities for high accuracy temperature measurements with incredibly low measurement uncertainties and capability is established to plus or minus 3 millikelvin, 0.003 degrees Celsius, for the temperature ranging from minus 196 degrees Celsius to 420 degrees Celsius. We can provide precision relative humidity measurements from 10% relative humidity to 95% relative humidity, with temperature range of minus 20 degrees Celsius up to 60 degrees Celsius, with an accuracy better than 1% relative humidity together with dew point capability. The ARM also has an impressive pressure calibration with capability ranges from minus 0.95 to 1,100 bar pressure range with an accuracy of 0.05 millibar. Our vision is to be the most reliable partner in caring for and providing accurate measurements and solutions. ASEC Group, measure accurately to manage effectively.
Berani menjadi yang pertama adalah kunci untuk membuka peluang yang tak terbatas. Peluang untuk menjelajahi horizon baru. Sejak tahun 1956, Sukovindo telah menjadi perusahaan testing, inspection, and certification terdepan di Indonesia. Memberikan pemastian dan rasa aman agar pelanggan dapat fokus pada bisnis. Setiap langkah adalah bagian dari perjalanan besar dalam menciptakan ekosistem perindustrian yang kompetitif dan berkelanjutan. Perjalanan itu menghantarkan kami hingga saat ini. Kami adalah perusahaan TIC terbesar dengan jaringan layanan terluas di Indonesia, mencakup semua tahapan proses bisnis, mulai dari tahap prainvestasi, pembangunan, produksi, hingga distribusi. Memberikan kepastian bagi sektor industri melalui jasa inspeksi, pengujian, sertifikasi, konsultansi, dan pelatihan. Memberikan kepastian bahwa setiap produk dan tahap proses bisnis memenuhi standar kualitas, kesehatan, keselamatan kerja, perlindungan lingkungan, serta peraturan yang berlaku di berbagai sektor industri. Mempertahankan integritas dan kompetensi dalam melayani, mendorong pertumbuhan pelanggan, dan memberikan rasa aman melalui sertifikasi produk. Setiap tantangan kami taklukkan sebagai komitmen dalam memberikan yang terbaik. Melangkah maju dan tanpa henti. Dunia yang terus berubah, demikian juga kami. Adaptif, menciptakan solusi untuk menjawab kebutuhan pasar yang terus berkembang. Inovatif, memperluas jangkauan dan dampak melalui transformasi operasional. Solutif, mendukung pelanggan untuk mencapai target keberlanjutan dan pertumbuhan usaha. Dedikatif, memberdayakan masyarakat, memperkuat ekonomi lokal, dan melestarikan lingkungan merupakan tanggung jawab sosial kami. Jaga integritas dan reputasi bisnis Anda, itulah yang kami lakukan. Sukovindo, assure your confidence.
Kehidupan masyarakat dunia di era peralihan masih menggunakan peralatan sederhana dalam kesehariannya. Ilmu pengukuran atau metrologi sudah dikenal sejak zaman dahulu dengan menggunakan metode pengukuran sederhana dan menetapkan standar yang digunakan untuk memudahkan proses produksi barang, pembangunan infrastruktur, hingga memperlancar transaksi perdagangan. Revolusi industri yang berawal di Eropa membuat ilmu pengukuran terus dikembangkan oleh para ilmuwan. Bermula dari konvensi meter di Perancis, penelitian dan perkembangan meteorologi semakin cepat dan pengaruhnya menyebar ke seluruh penjuru dunia. Peranan meteorologi modern juga telah sampai di bumi pertiwi sejak zaman kolonial. Meteorologi digunakan untuk memperlancar kegiatan perdagangan rempah-rempah dan pembangunan infrastruktur seperti jalan raya, pembuatan rel kereta, dan sarana umum lainnya. Pasca kemerdekaan Indonesia, meteorologi terus mengiringi perjalanan pembangunan negara. Melalui peranan meteorologi, Indonesia melakukan berbagai rencana pembangunan strategis untuk meningkatkan perekonomian negara dan mencapai kemandirian teknologi serta kemandirian pangan. Pada tahun 1997, Indonesia mencetuskan untuk meningkatkan pembangunan melalui standarisasi sehingga menjadi awal mula pembentukan Badan Standarisasi Nasional. Melalui Undang-Undang Nomor 20 Tahun 2014, Badan Standarisasi Nasional mengemban amanat negara dalam mengelola standarisasi dan penilaian kesesuaian. Hal tersebut sejalan dengan rencana negara Indonesia untuk terus meningkatkan kemandirian sumber daya manusia, kemandirian pangan, kemandirian teknologi, dan kemandirian ekonomi secara menyeluruh untuk mencapai cita-cita generasi Indonesia emas. Badan Standarisasi Nasional melalui Deputi Bidang Standar Nasional Satuan Ukuran adalah lembaga negara yang memiliki peranan untuk mengelola standar nasional satuan ukuran berlaku sebagai National Meteorology Institute atau NMI, di mana seluruh hasil pengukuran yang ada di Indonesia dapat tertelusur ke sistem internasional. Peta kekuatan SNSU-BSN dalam mengelola meteorologi di Indonesia saat ini terbagi menjadi dua, yaitu Direktorat Mekanika Radiasi dan Biologi yang memiliki 254 lingkup pengukuran, 38 personel laboratorium, memiliki 69 CMC, dan telah menerbitkan lebih dari 680 sertifikat per tahunnya melalui Laboratorium Massa dan Turunannya, Laboratorium Akustik dan Vibrasi, Laboratorium Panjang, Laboratorium Biologi yang membuka layanan untuk uji profisiensi. Direktorat Termoelektrik dan Kimia yang memiliki 130 lingkup pengukuran, 49 personil laboratorium, memiliki 78 CMC, dan telah menerbitkan lebih dari 650 sertifikat per tahunnya melalui Laboratorium Suhu, Laboratorium Waktu dan Frekuensi, Laboratorium Kelistrikan, Laboratorium Fotometri dan Radiometri, dan Laboratorium Kimia yang juga membuka layanan uji profisiensi. Badan Standarisasi Nasional terus berkomitmen untuk mengelola standar nasional satuan ukuran dan melayani masyarakat Indonesia demi kemajuan bangsa dan negara.
ASEC Group is a one-house solution provider for all your instrumentation and calibration needs. At ASEC Group, we understand that precise measurements are essential and critical for your business long-term success and sustainability. That's why we bring a comprehensive range of products and services covering diverse measurement and control aspects, including temperature, humidity, pressure, flow, level, air quality, and more. We have two distinct business units, ASEC Instruments and Isolab Singapore, each with a different focus. Our business operates through three well-established in-house brands to cater to different customer segments and applications. ASEC Sensing is our brand of custom-made high-accuracy temperature sensors, including green building applications, explosion-proof sensors, and thermowells to comply with industry standards and certifications. Blue Gizmo is our dedicated brand with a range of portable instrument and data acquisition systems trusted in food, HVAC, cold chain, and warehousing industries. Taisho focuses on process and control instrumentation with precision sensors that can be integrated with various systems. Isotech. We also provide calibration and testing services through our sister company, ISOLAB Singapore. ISOLAB is an ISO IEC 17025 accredited laboratory with dedicated expertise in calibrating a wide range of instruments, including temperature, humidity, pressure, electrical, stopwatches, timers, airflow, and sound level. ISOLAB can perform on-site calibration and temperature mapping for mega warehouse sizes, cold chain storage, and transportation facilities. Our in-house calibration capabilities at ISOLAB are actively upgraded to calibrate standard PRTs using ITS 90 fixed points. ISOLAB's capabilities for high accuracy temperature measurements with incredibly low measurement uncertainties and capability is established to plus or minus 3 millikelvin, 0.003 degrees Celsius, for the temperature ranging from minus 196 degrees Celsius to 420 degrees Celsius. We can provide precision relative humidity measurements from 10% relative humidity to 95% relative humidity, with temperature range of minus 20 degrees Celsius up to 60 degrees Celsius, with an accuracy better than 1% relative humidity together with dew point capability. The ARM also has an impressive pressure calibration with capability ranges from minus 0.95 to 1,100 bar pressure range with an accuracy of 0.05 millibar. Our vision is to be the most reliable partner in caring for and providing accurate measurements and solutions. ASEC Group, measure accurately to manage effectively.
Berani menjadi yang pertama adalah kunci untuk membuka peluang yang tak terbatas. Peluang untuk menjelajahi horizon baru. Sejak tahun 1956, Sukovindo telah menjadi perusahaan testing, inspection, and certification terdepan di Indonesia. Memberikan pemastian dan rasa aman agar pelanggan dapat fokus pada bisnis. Setiap langkah adalah bagian dari perjalanan besar dalam menciptakan ekosistem perindustrian yang kompetitif dan berkelanjutan. Perjalanan itu menghantarkan kami hingga saat ini. Kami adalah perusahaan TIC terbesar dengan jaringan layanan terluas di Indonesia, mencakup semua tahapan proses bisnis, mulai dari tahap prainvestasi, pembangunan, produksi, hingga distribusi. Memberikan kepastian bagi sektor industri melalui jasa inspeksi, pengujian, sertifikasi, konsultansi, dan pelatihan. Memberikan kepastian bahwa setiap produk dan tahap proses bisnis memenuhi standar kualitas, kesehatan, keselamatan kerja, perlindungan lingkungan, serta peraturan yang berlaku di berbagai sektor industri. Mempertahankan integritas dan kompetensi dalam melayani, mendorong pertumbuhan pelanggan, dan memberikan rasa aman melalui sertifikasi produk. Setiap tantangan kami taklukkan sebagai komitmen dalam memberikan yang terbaik. Melangkah maju dan tanpa henti. Dunia yang terus berubah, demikian juga kami. Adaptif, menciptakan solusi untuk menjawab kebutuhan pasar yang terus berkembang. Inovatif, memperluas jangkauan dan dampak melalui transformasi operasional. Solutif, mendukung pelanggan untuk mencapai target keberlanjutan dan pertumbuhan usaha. Dedikatif, memberdayakan masyarakat, memperkuat ekonomi lokal, dan melestarikan lingkungan merupakan tanggung jawab sosial kami. Jaga integritas dan reputasi bisnis Anda, itulah yang kami lakukan. Sukovindo, assure your confidence.
Ladies and gentlemen, if you already grabbed your refreshment, I invite you back to join us inside the room because we will start our first session in a moment. So ladies and gentlemen, after you finish grabbing your refreshment, you can come inside and then bring your refreshment because we will start the first session shortly. Assalamualaikum warahmatullahi wabarakatuh. Welcome back everyone. Before we continue with the first session, I would like to express our sincere appreciation to our sponsors, AZEC Instruments Pty Ltd, PT Sukovindo Persero, and PT Gencraft Labs. Please give a round of applause for our sponsors. And you guys can visit their booth behind of the auditorium, maybe during the lunchtime, and then you can ask whatever questions you want to ask, you want to know, and you want to get from them. Thank you. Ladies and gentlemen, now we will start the first technical session. This session will feature presentations from our great speakers, and they are Mr. Kyu Tae Kim, Principal Research Scientist, Korea Research Institute of Standards and Science of South Korea. Also, we have Mr. Hugo Adams, National Measurement Institute, Australia. And then Mrs. Oichai Ongrai, APMP-EEFG Chair, National Institute of Meteorology, Thailand. Also, Mr. Arfan Sindu Tistomo, SNSU-BSN, Indonesia. And to lead this session, I kindly invite Mr. Aditya Ahmadi from SNSU-BSN to serve as session moderator. Let's give up a round of applause for our moderator today, Mr. Aditya Ahmadi.
Okay, thank you very much, Mr. Reza, for kind introduction. Good morning, distinguished guests, ladies and gentlemen. I'm Aditya Ahmadi. Allow me to stand in front of you as the moderator for this technical session. And it is a pleasure to welcome you to this technical session. Hope we have some discussion, because in this session we have four speakers, a distinguished speaker. And then I also, in this, for this session, I will invite the speaker one by one. So, and then every speaker, we will have short Q&A session. So prepare if you have any question. And don't forget, our committee was prepare a door prize. So for you who ask the first three question, if you ask something, and then you will have some door prize from the committee of this event. And then for the first speaker, allow me to, it's my pleasure to invite our first presenter. He is Dr. Kyu Tae Kim. Now his position is Principal Research Scientist at Korean Research Institute of Standard and Science, KRIS, and Department Quantum Research Institute. He earned his PhD from Korea Advanced Institute of Science, KAIST. And Dr. Kim has very extensive experience also as lecturer at Korea National University of Science and Technology, Hannam University, and also many experience in meteorology. He also has technical peer review for many National Meteorology Institute at the globe, and also served as assessor for the Korea Laboratory Accreditation Scheme. As professional role, he also has experience as secretary of the Korean National Committee of IEC TC 85 and members in several scientific society. And today, he will share insight on the smart grid and electrical vehicle station traceability. And then to Dr. Kyu Tae Kim, please to join me in the stage. And the stage is yours.
Thank you. Thank you, coordinator. It's my pleasure to be here to share some of my idea on smart grid and EV traceability. My name is Kyu Tae Kim, and Hyung-Kyu Lee is the leader, group leader. Okay, actually it's my second visit here. Impressed the rapid development and huge changes here. And I deeply thank to EEFG organizer and chairperson. Okay, today my talk will begin with background of smart grid and EV station and this current standard in Greece. And this the power and energy standard in Greece. Next, please. Okay, smart grid. It should all encompass the diverse supply and demand. So the power quality monitoring and control is very important. This one. Okay. The key concept of smart grid, as you know well, it moves from one-way flow of electricity to a two-way flow of electricity and information. The smart grid integrates sensors and smart meters and digital communication throughout the network. This allows the real-time monitoring, automated response to issues, and communication with the consumers. The key component of the smart grid is, we can say, smart meters, advanced metering infrastructure, distributed energy resources, like solar panels. But challenge is these resources are not always constant, so it can produce instability of the power grid. So we need to more smart grid to solve these problems. So here in Korea, we have some example of the grid problem. The Korea is facing significant challenges in its energy transition due to underdeveloped power grid. This is causing a large amount of renewable energy to be wasted. Although we built huge solar panels, it produces, but there are no sufficient grid. So all the energy now is wasted. There's a big problem. So it shows how grid is important. Okay, so now I'd like to turn to the topic on EV. EVSE stands for electric vehicle supply equipment, and it has 3 levels. Level 1 uses standard 120 volt outlet. Level 2 EVSE uses 240 volt utility outlet, and level 3 it enables us DC fast charging with higher voltage and higher current. For level 1 and 2, we need onboard charger in the electric vehicle, but for level 3, DC power is directly going to the battery of the EV. So by using DC technology, we can achieve very fast charging. For 80% charging, we can easily go to or reach to 30 to 60 minutes charging time, and it ensures longer distance travel. So this charging power increasing is growing very fast. So at the time of 2024, the maximum charging power reaches 350 kilowatt. Okay, and there are several global standards: IEC, ISO, SAE, and UL. And according to the standard, there is a plug type there. Korea using CCS type, similar to the North America. The combo type called CCS is used in Europe and North America, and CHAdeMO is used for Japan, GBT used in China, Tesla used for Tesla. Okay. Some description of the key features of these different types. In Korea, the fast charging stations are very increasing very rapidly, and in the year of 2021, the number of fast chargers reached about 10,000, but this year it tripled. It's more than 30,000 chargers. The government started to support the standard for EV chargers. The regulations are started already, and the traceability of the standardization looks like this chart. Korea Agency for Technology and Standards, we call ATS. So now governing all the standardization framework. And the CRIS is a National Meteorology Institute of technical side, and we provide meteorological traceability. The calibration and testing service are carried out by two major institutes, KTL and KTC, and CRIS provide calibration certificate for their reference meters. The major measurement points in the EV, DC EV, we need to measure input power, DC output power, energy consumption, and so on. But for traceability of standards, this power is very important. So in CRIS, we maintain primary standards for this power, and KTL, KTC, they have secondary standards, and they are used for field calibrations. The reference standard of the KTL and KTC looks like this. Acara comes 3003 is a power meter. We provide calibration up to 1000 volt and 500 ampere. Few is 2 years ago, but now they wanted higher range, so we provide 1500 volt and 1000 ampere. Actually, the maximum input voltage is 500 volt, and the input current is 160 ampere. So the actual device under test is not exact one. They modify to extend the input voltage and input current. So they attach DC voltage divider and DC current transformer at the input terminals. So slightly modified one is my DUT. The DC current standard increase is shown here. The CMC covers 100 ampere to 30,000 ampere with 0.02% uncertainty. We use guild line DC current source is a current extender of DCC bridge, maximum 4,000 ampere. And we are using guild line DCCT as our DC high current reference. It provides the ratio 500, 100, and 1,000 to 1 up to 3,000 ampere. And we are measuring the CT ratios with our standard registers, Tinsley and guild line, with several resistance values. And voltage measured with digital multimeter. Okay, we developed Anton input device for calibration of DCCT. The CT ratio is defined by the current ratio between output and input. So input current divided by output current. But current is measured by the voltage and resistance. So it means the DCCT ratio is expressed as a resistance ratio times voltage ratio. Well, for high current resistors, it's very difficult to get good accuracy and stability. So it's better to use this standard resistor at lower current. With using Anton input device, we can lower the test current n times lower. That's the basic idea. So there's several types of Anton device we are using. This is a simulation for heat, maximum heat simulation. So the feasibility check of this input device, we compare the two measurement results. One is using direct input to the DCCT, and the other is the test current is through the Anton. Here what we experiment is an Anton input device. So by comparison of these two results, we can obtain the N value of Anton device. For this measurement, we obtained the value of -1 ppm only. The relative difference from the expected one is 1 ppm from this experiment. So we can use this Anton input method, and also we can use direct method, and there is some comparison of our 1,000 to 1 ratios. These two methods shows very good agreement within approximately 5 ppm. Okay, this is a calibration system for DC power. The DC current is the key component for the DC power, but we also need to measure the voltage. So for 1,000 volt, up to 1,000 volt, we can use the output from multifunction calibrator directly, and the DUT generate our frequency, pulse frequency. We measure the pulse frequency for a voltage, for the test voltage and test current, and we measure the frequency. We measure the voltage and frequency. We can calculate the expected frequency. So the relative difference of the output frequency from the expected one is relative difference, relative error of power of the DUT.
Dr. Kim, we have 3 minutes left.
Okay, thank you. Okay, this is a photo of our calibration system, and the last one. Yeah. This is extended system for extended voltage, and the expanded uncertainty we evaluated 0.02% for DC power. Okay. Well, thank you.
Okay, thank you. Big applause to Dr. Kim. Thank you very much. Please have a seat, Dr. Kim. You can sit, yeah. Okay, thank you very much for the insight about how to calibrate the DCC and then how Chris can fulfill the traceability for calibration. If from the floor there are any questions, please, you can ask now. We have a short Q&A session now for Dr. Kim. Yes, we have door prize actually. Yeah, I just remind. Oh, okay. Yes, Mrs. Ochai, please. Yeah. Please for the mic.
I want the prize, and I want to ask as well. So as you can see that in Asia Pacific, like Thailand and Indonesia, we are expanding to have EV car and EV station chargers. What the methodological challenge that you think that you can foresee for support this? Yes.
A good question. My experience in carriage service is, in my feeling, there is some condition difference between calibration and the field. For example, the DC current. So this current, at the field, they are mostly using DC shunt, but it's very unstable at the temperature. At the site temperature, the temperature is not very well controlled. But in the calibration, we always use constant controlled environment. So it's my challenge how to deliver the correct standard to the field. Yeah, it's a bit challenging.
Thank you. That's a very good point. Thank you very much.
Yeah, thank you very much, Dr. Ochai, for the question and also the answer for Dr. Kim. So the environmental is the challenging, very challenging, the condition. Okay, I think we have enough time. Thank you very much to Dr. Kim for the presentation. Thank you very much. Big applause to Dr. Kim. Yeah, yes. And then we will move to the second presentation. Will be delivered by Mr. Hugo Adams. And then he is the experimental scientist or electrical engineer at National Measurement Institute Australia, NMIA, in the Department of Power System Technology. He completed a double bachelor degree in electrical and electronic engineering as well as in mathematics. So it's very interesting, yeah? Double degree in engineering and mathematics. He has contributed to a number of exciting projects in the field of power system measurement and technology, and therefore today he will presenting on the on-site high voltage test for synchronous condenser. And then please join me in Mr. Hugo to in the stage, and please give applause to Dr. Hugo. Please, yeah. You can sit here and then please. This is yours. Yeah, you also. Okay. Oh, you need. Sorry. You need the stage, but the podium. Okay. Okay. Please prepare the podium for Mr. Hugo. Yeah. Okay.
Yeah, thank you.
Yeah. Actually, if you prepare both, yeah. If you like to in podium, it's okay, and if you like, okay, please. Yeah.
All right. Thank you. Yeah. Right. Good morning, everybody. Thank you so much for being here today. It's an honor and a pleasure to be presenting in front of you guys today to such a wide range of experts. I'd like to thank BSN and APMP for putting on such an incredible symposium, and as well as NMIA for allowing me to come out here today and talk about some of the work that we do. So my name is Hugo Adams. I'm an electrical engineer at the National Measurement Institute of Australia. I work in electrical metrology in the high voltage laboratory. We have capabilities where we can test AC voltages up to 800,000 volts, 1 megavolt DC, and 3 megavolts impulse voltages. And so with these capabilities, we test and calibrate a whole range of instruments and devices that are used in our energy grid, including high voltage capacitors, voltage and current transformers, instrument transformer test sets, and insulation materials. And a big part of this job is doing on-site testing. It's something that we get inquiries for all the time from transmission and distribution companies in Australia to come and do testing and calibration for their devices that are out in the field. Since these devices are quite often very hard to ship and quite expensive as well. We quite often go out there and do the testing for them. One particular inquiry that we got a number of years ago is concerned with these devices called synchronous condensers. These are devices that I'll talk about a lot in this presentation, but I thought it would be quite relevant to the discussions here today because they're devices that are popping up all over Australia's energy grid to help stabilise the energy grid with all of the renewables coming online. And I'll talk a little bit more about what that stability means. So yeah, there will be parts of this discussion where I will get a little bit technical, which I hope is okay. But if you do have any questions later on, feel free to ask me later or even later in the workshop as well. So perhaps the best way for me to start this is by introducing the problem and motivating the reason why we need synchronous condensers on our grid. So just a few statistics. Australia's energy grid last year in 2024, 40% of the energy was supplied with renewables. So that's the hydro, solar, wind, bioenergy as well. Out of that 40%, it was highly dominated by solar. About 20% of it was all solar. And then about 13% was wind. So, I mean, if there's one thing that Australia has, it's a lot of land and a lot of sun. So solar is a really big dominating force in the renewable space for Australia. Out of this percentage as well, about 12% of the energy production was just from rooftop solar. So that's domestic solar production. So individuals, businesses, they get solar panels on their roofs and service their own energy use with that, but then also feed back some of that to the grid. This is a map of Australia. I've put a little box there where the section of Australia where I'm from, in that bottom right corner, and then zoomed in a little bit as well to show you just the scale of energy production going on in Australia at the moment. Historically, Australia's energy grid was very centralised, meaning all of the energy pretty much was serviced by a very small number of very large coal power plants. However, as we're moving more into renewables, we're getting a lot more distributed energy resources around the area. So just this little area of Australia has all of these energy sources around it. So you can see a lot of solar, a lot of wind, a lot of battery energy as well, just in this one little pocket. And this is good. We want this. This brings our renewable energy up and takes coal power plants offline. So we can hit our 2050 net zero target a lot sooner. Oops. This does, however, create issues because these distributed energy resources are interfaced to the grid via power electronic converters. These power electronic converters are very complex in nature. They use switching operations to transfer the voltage waveforms to something that the grid can accept. They're very non-linear and they're multi-dimensional, which makes modelling these things very, very tricky, especially when we're talking about slow and fast transients on the electricity grid. So essentially their behaviour is very unknown and questionable in certain circumstances. Not only that, but there are stability issues that arise with these converters. The ones that I'll be talking about today are mainly voltage and frequency stability. There are other stability problems like rotor angle stability and converter-driven stability and sub-resonance stability that have been introduced recently by the IEEE. However, those three I won't talk about today because it's not really in the scope of the synchronous condenser discussion. Really, the problem with frequency stability is that there's no inertia on the grid. With all of these synchronous condensers, so all of these synchronous machines coming offline, there's no more inertia on the grid to provide short circuit power for loads that are dynamically changing on Australia's grid. This can result in large voltage fluctuations, big dips, and big increases, and in some cases can lead to a total blackout in Australia's grid if the load and the supply are not sufficiently matched. There are, however, lots of ways that this behaviour can be fixed. Some of them are better than others, and in Australia I've got 4 here that I've sort of outlined a little bit that we use quite a lot, have used historically and are using now and into the future as well. So one of the biggest ones that we've used historically is grid-forming inverters. These grid-forming inverters generate synthetic inertia, so short-circuit capacity on the grid via the BESS or the PV array that it's connected to. This short-circuit capacity is not immediate though, because these grid-forming inverters are power electronic converters themselves, and these have certain measurement and computational systems associated with them which introduce time delays. So for super fast transients, like a lightning strike, these inverters are not great at adapting to that. We've also got static VAR compensators. These compensators are just set inductors and capacitors that are connected directly to the electricity grid via a thyristor-controlled switch, so you can switch them in and out. And this compensates for reactances that the source is seeing from to the load. So this can take away reactive power or introduce reactive power onto the grid, which helps stabilise these voltage fluctuations. These are very, because they're fixed inductors or fixed capacitors, there's very low flexibility with these devices, but they're very easy to implement and very cheap as well. There's also a StatCom. I'm sure you've all heard of a StatCom. It's a lot more flexible version of a static VAR compensator. It's a switch mode converter that can control the inductive or capacitive current being injected into the grid. This, however, does not provide any of the inertia, which helps with the frequency stability that I talked about before. Synchronous condensers are the answer to all of this, though. They help with frequency stability because they have a lot of inertia associated with them, but they also help with voltage stability as well, because you can change the excitation of the rotor to make it look inductive or make it look capacitive from the grid's perspective. So what is a synchronous condenser? They are synchronous machines, pretty much, just like what we've had all over our electricity grid for many, many decades. However, these synchronous machines aren't connected to anything. They just have a big, heavy rotor connected to a flywheel, and they're not consuming any real power. They're just spinning freely. And the beauty of this is that we can actually control the excitation in the rotor to make it look inductive or capacitive, as I said before. And I've got a few phasor diagrams there to show it. So if you lower the excitation, you lower the current running through the rotor, you'll change the EA vector and the IA vector in there, and you can make it consume reactive power or absorb reactive power. So it helps with the power factor correction there. Not only that, but these synchronous condensers also provide a lot of short-circuit power as well, which helps with the frequency stability. Here I've got a little plot of a few different cases of when the frequency does unsynchronize with the grid. You can see that the green line there, the frequency drops a lot more and then oscillates quite a lot, which is a situation that we don't want. What we want is a situation more like the red line, where if a load is switched in or switched out, the frequency dips a little bit, and then the overdamped response returns back to the nominal frequency as we want. And this is something that we get with the synchronous condensers, because it is a large mass spinning with the rotor and the flywheel. So once a load is switched in, the synchronous condenser will slow down a little bit, or it will speed up a little bit. and provide short circuit power for that load until the voltage raises up and then everything goes back to normal. Before, without these synchronous condensers, the grid forming inverter, for instance, doesn't have the short circuit capacity that is requested by significantly large changes in load. And so what will happen is the voltage on the grid will dip and wait for the load voltage to increase again. And that's when we get those blackouts, like I said before. So that's what a synchronous condenser is, and that's how they work. Now I'll talk a little bit about the tests that we did when we went onto site. So really, all the tests that we did on site were to do with the stator windings, to make sure that the insulation in the stator windings was correct, and also some partial discharge testing as well. Partial discharging, for those that don't know, is a phenomenon that occurs in high voltage systems where small current spikes are seen, which can damage the insulation. So we have to make sure this partial discharge is within a certain limit, and those limits are defined by the international standard. And there I've just listed a few different sources of partial discharge as well, so voids, debonding, foreign materials, all that stuff. So this is stuff that we're checking with these high voltage tests before we actually apply voltage to it and make sure it's not going to break. So this is an outline of the tests that we ran. These are tests that are in 60034, which is the international standard around rotating machines. The three tests that we did were a high voltage withstand test. So we put voltage on the stator and make sure it doesn't flash over. By the way, in this table, UN is the nominal rated voltage, and in our case was 12 kV with the synchronous condensers that we're testing. So for the withstand test, we applied 25 kV for 1 minute. After the withstand test, we did the dielectric dissipation factor test. This is essentially just a capacitance measurement test. We measure the capacitance and then the loss angle associated with that insulation. And this is done all the way from 0.2 times the rated voltage all the way up to 1.2. So that's 2.4 up to 14.4 kV. And then finally, the partial discharge test I spoke about. You just apply the up to the nominal voltage and make sure that it's within a certain limit. In this case, 6,000 picocoulombs of PD is what we're looking for. So these are all tests that we do before the actual SynCon is connected to the electricity grid. Once it is connected and once it has been turned on, we then do a commissioning test, which is just another withstand test pretty much. So I'll talk about each of these tests a little bit. This is sort of where it might get a little bit technical, but I won't talk about it too much. Basically, the withstand test is put the high voltage on the stator, on each stator winding, and make sure it doesn't flash over. The interesting thing about this one is that we employ the use of a resonant test set on our on-site high voltage tests. And the reason we do that is because traditional high voltage sources are generally very big. They've got a lot of iron, a lot of coils in them, so they're very heavy to move. Not a lot of fun to put on site. So what we do is use a resonant test set where we have a much smaller high voltage source, about 400 volts, and feed that into a transformer. The transformer generates about 1 kV for us. And then from there, we match the capacitance that is seen by the insulation of the SynCon, which is about 1,000 nanofarads, with the associated inductance that results in resonance of 50 hertz at power frequency. So you can see there it's about 10 henries is the inductance that we calculated, and this causes the thing to resonate at 50 hertz, which is good.
Mr. Luca, we have 5 minutes left.
So yeah, the withstand test is quite simple. You just put the voltage there and wait for a minute and make sure it doesn't flash over. For the DDF measurement, This is a little bit more complicated. Again, you put the high voltage on the stator windings, and then you put a standard capacitor to ground, or not to ground, from the high voltage to our capacitance bridge, and then compare that with the capacitance associated with the windings. So you can measure the capacitance by comparing it with a standard capacitor. And these values are fed into a capacitance bridge, which we balance manually and then calculate the capacitance and the loss angle as well. There's also a current transformer that I've put there in that schematic. That just is there because the bridge can only take a certain amount of current and we had to step it down. So it will add to our uncertainties, but it's for the purposes of on-site testing, we're well within the uncertainties that the people requested. These are the results. You see it's about a little bit less than 1 millifarad, 1 microfarad, sorry. And the loss angle is quite small. That's because the parasitic resistance in parallel with the capacitance is very, very small, and the loss angle is just the ratio of these two. And that's at different voltages as well, and you do it on each phase as well to make sure each phase is okay. And these are the uncertainties associated with it. If we're at our best, we can achieve 15 ppm uncertainties for the capacitance and that uncertainty for the loss angle. On site, obviously, it's not going to be that good, but they are good enough for the people that were requesting this test. This is PD. Again, you put the high voltage on one of the phases. You have a coupling capacitor on the other side of the phase, and then a measuring impedance. So once this current pulse occurs in the insulation, this is filtered out by the coupling capacitor, and only the high frequency is left, and then that measuring impedance turns that current into a voltage that we can measure. And then this step voltage is essentially the PD that we're measuring as we ramp the voltage up. And this is the circuit again here. Yeah. So yeah, you apply the high voltage on U2, you measure the PD at U1, which is the other side of the phase, and you do that for each phase as well. And this is what a typical PD measurement pattern looks like. Yeah, it gets quite high when the voltage is maximum, and then it just dips off again, as you'd expect. And you can see all of these ones pass because they were underneath 6,000 picocoulombs. So in summary, these syncons are becoming a lot more prominent in Australia's electricity grid. I think there's about 40 more planned to be installed along the east coast of Australia, which me and my team are going to be testing. They help stabilise the grid voltage through the use of voltage stability and frequency stability. They provide inertia and short circuit capacity to help with these things. And you can change its rotor excitation to help with that voltage stability. Yeah, they undergo quite technical testing and measurement services from us to make sure that they work in operation. Yeah. And like I said at the beginning, if you have any questions about this stuff, feel free to talk to me right now or later on in the workshop. I'd be very happy to answer any questions and have a chat. Thank you.
Okay, please give applause to Mr. Hugo Adams and Mr. Sit. We're waiting for the question. If from the floor there are any questions, please raise your hand. Oh, okay, good. Okay, please give the mic to the question.
Thank you for your explanation. I'm not from the electrical field, but I'm curious.
You can let us know your name and where you're from.
Yeah. My name is Ramalisa. I am from the Academy Electromedical Engineering Andakara. So I want to ask to you, because I'm not from the electrical field, but I'm curious, how does a synchronous condenser actually sense and adjust to maintain voltage stability in the grid, for example, in the hospital? That's the question. Thank you.
Okay, you can directly answer the question.
Yeah, thank you. Thank you for that question. So when you can imagine with these synchronous machines and coal-fired power plants running, big loads get switched in and out of the network all the time. These loads act to slow down or speed up the machine that's running because they change the electromechanical torque that the machine is experiencing. And this provides a lot of short circuit power to help raise the voltage up for that load that's just been switched in. And this is how it works traditionally. However, with all the converter interface generation going on in Australia, a lot of blackouts were happening, and indeed where I'm from, a lot of blackouts did happen for a while because this is exactly what was happening. There was a lot of inrush currents whenever people were switching loads in and out, causing tripping to happening because the voltage sags and then something trips upstream. So these synchronous condensers, the idea behind them is that you don't get rid of the rotating machines, you keep them in there, but you can use them in such a way that they look reactive, so they look inductive or they look capacitive from the grid's perspective. And the way that helps is by providing reactive power or absorbing reactive power when these loads get switched in. And that stabilizes the voltage because there's power going to the load under these short circuit conditions. And the grid stays fairly constant as well. And there are certain things you need to look at when you're buying these synchronous condensers, like the inertial response, to make sure that, you know, if a certain load is switched in, it still remains on and things don't trip properly. But yeah, that's basically how it gets done. It's absorbing reactive power or emitting reactive power to the grid to supply those loads that get switched in and out. Yeah.
Okay, the answer is okay. Okay, it's clear. I think there are any other question. Yeah, please.
Okay.
Can you handle? Yeah, okay, please. Yeah. Yeah.
Okay. Good day, Hugo. Name is Hardy. Would like to ask several questions regarding the voltage withstand test. The first question is that I would like to ask you, how often do you do the test itself? And is it regulatory in the government of Australia, or is it like something that probably the company want to do the test, or yeah, probably something like that? And the next question is that the grid in Australia, I'm aware that there are several grids in terms of, in the arena itself, it has the main grid from New South Wales to the South Australia, and you have a different grid in the western part of Australia as well, and the Northern Territory. Does it also do the test, the voltage test itself? Okay, thank you very much for that.
Thank you so much for your question, and g'day. G'day. So to answer your first question, yeah, the high voltage withstand test is by far the most common test that we do. Lots of manufacturers, not just for the synchronous condensers, request that sort of test for their equipment. It's very typical for insulation to get tested with that sort of test, because it basically verifies very well if the insulation is gonna work or not. Yeah, so it's something that we do daily. Different types of voltages and even different voltage shapes. Like we're just talking about AC withstand here. We do DC withstand and impulse withstand voltage tests as well, which verify that the instrumentation or the insulation will work well under a transient condition. So yeah, it's very, very common. It's a standardized test as well. It's not just something that Australia does. I think it's one of the standards, IEC 60-1, outlines this stuff very, very well. Yeah. And then your other question, what was that in regards to again, sorry?
Sorry about that.
No, you're right.
The national grid.
Yes, of course, sorry.
Okay.
Historically, Australia's energy grid was very centralised. So New South Wales had its own electricity grid, Victoria had its own electricity grid, Queensland, all the states, they all had their own electricity grid going on, and there was different transmission companies as well that looked after all of that. But now, with this renewable stuff coming on, there's a really massive project going on where they're actually connecting New South Wales, Victoria and South Australia. This is called Project Energy Connect, and this is something that we actually did do this synchronous condenser test for, because with all of these grids getting connected together, you can get a lot of instability happening because of it. So we need to make sure that these synchronous condensers are working properly. At the moment, I don't know if there's any plans to connect Western Australia with Northern Territory or Western Australia with South Australia. I'm not aware of that, but I bet there probably will be plans to do that in the future. Yeah.
Yeah. Okay. Thank you.
Thank you.
Okay. Thank you very much for the question, Mr. Ardi. Yeah. So Mr. Ardi is our colleague in BSN. Yeah. Okay. Thank you very much, Hugo. And then because we have enough time, so thank you very much for your presentation. It's very delightful and comprehensive. And we will go to another presenter. And then so you can back to your chair. Thank you very much. Give applause to Hugo. Yeah. Okay, for the next presenter. For the next presenter, we have Dr. Ochai Ongrai. He is the APMP Energy Efficiency Focus Group Chair and also Head of Temperature Laboratory at National Institute of Meteorology, NIMT, Thailand, Department Thermometry and Optical Meteorology Department. She earned his PhD in physics at Advanced Technology Institute, University of Surrey, UK. And his experience, is very long time ago from 2003 at meteorology, so it's very extensive experience. And then he also has been deeply engaged with the APMP Energy Efficiency Focus Group for serving as coordinator, vice chair, and currently the chair. So today she will sharing insight about the methodology for renewable energy transition in Thailand. So please welcome Dr. Ochai to the stage, and please give applause for Dr. Ochai. Please.
Okay. Good morning again, everyone, and thank you to be here joining me this session. Today, I would like to share you how Thailand moved toward to renewable energy and how meteorology support this journey. Next slide, please. For today, I'm going to link between energy and meteorology, Thailand energy strategy and meteorology development, and the role of APMP-EEFG, and some example for you of how we collaborate to our stakeholder. And before we begin, we would like to remind you a little bit that we are meteorology, that quite close word to meteorology, yeah? what the difference, because we are dealing with the measurement size, but meteorology, we are working close together. They're doing about the atmospheric size. So we are quite similar word, but it's slightly different. Okay. Most of us are familiar with fossil fuel and coal and petroleum, but however, nowadays it is difficult for any single country can use only one energy source, right, to meet energy demand. That we need a diverse mix of alternative energy and energy action plan that appropriate for our local conditions and also time of adoption. As you can heard that hydrogen already adoption in Australia and also Korea, but in Thailand we are still planning on this, and I think here in Indonesia as well. So this is like what we have to do in different states, but we try to do the same thing to make the standard of measurement. So across Asia, we are moving fast toward to energy transition, and like Thailand and Indonesia, we both widely implement on renewable energy, especially on solar energy, EV, and also in Thailand, we aim for carbon neutrality by 2050. How about in Indonesia? Anyone remember which year? You not get the prize. Okay, so I think on 2060. Yeah, so this policy and plan is already published in the action of Asian action. We need to check that when we go there and what we prepare in the future. So this transition needs a lot of effort, like national quality infrastructure, standards, safety application, the most efficiencies, and international energy distribution. If we plan to trading between Thailand to Vietnam or Indonesia to between Indonesia to Singapore or trading energy. So measurement is also very important to know that how much we pay and how can the dispute, how stable it is. Methodology can ensure that our energy system are reliable, testable, and also trust. So next please. I'm very excited at first because here, this is my first time in Indonesia. And I heard that it's the home of Asian Center of Energy, right, in Jakarta. So this is where we confirm the importance of policy of the Asian Plan Action that comply to the international government and policy. So I'm really glad I'm be here. I'm really big fan of ACE. So Indonesia and Thailand are the both part of the action of our energy, whether it's Asian power grid, energy efficiencies, and renewable energy. So this action is worldwide need a common IEC standard guideline where measurement is become really backbone of this specification and also the reliable energy data. Okay, next please. So I would like to show you, this is my office in Thailand. I stay in like a third floor here. Here. So in this building. In Thailand, in Nimti, we have two buildings, or now three buildings now. We have a home of measurement and standard that we serve with both the biological, chemistry, and also physical methodology as well. Because we believe that standard and quality can be achieved by starting from measurement accurately. So at NIMT, we maintain national standard traceable to the SI unit. Our customer or our stakeholder sending their working equipment to traceable to NIMT. And also our trust is across the country by intercomparison. I think Indonesia SNSU-BSN played a similar role. So working together in the future, I think we can harmonize the measurement system and support the regional energy innovation. Next, let me show you the policy direction in Thailand. For the Thailand, in the smart green energy policy, it includes the direction to encourage the industry to use clean energy. So if we point that we will go to carbon neutrality by 2050, so we have a plan of adoption more renewable energy, have more EV car, more percent of EV car adoption, 30% by 2030, and have energy efficiency reduced by 30%, and also another application of digital energy to be implemented in Thailand. So this needs a strong methodology. In addition, in the highlight in next year is about direct purchase. So we can the factory can direct purchase the energy from the clean energy producer. So methodology, you have to confirm how much energy comes from the clean source and also how much the carbon can be reduced. So this is important of how methodology and energy can be linked. Next, please. This is one example in Thailand. I'm not sure that how many electricity meter in Indonesia, but in Thailand it's about 21 million electricity meter. So at NIMT, we play the key role to developing and supporting the measurement technologies that ensure the system accuracy and reliability. NIMT provide the calibration service, testing, training, consultancy to our stakeholder to ensure the accuracy of electricity meter down to 0.5%. That make a lot of efficiency of that. So when we expand the renewable energy like a solar, wind, hydropower, we need to maintain the electricity grid stability that can come from many sources and even more essential for green energy. So NIMT support the power grid stability as well. So next, please. We support the power grid stability through the voltage, frequency, and phase alignment that's crucial for smart grid and EV station. We just start to doing something on EV charging station on 2023. So now we can developing the key guideline to our stakeholder under support from, we have an expert from Chris to NIMT to guide us and to be our speaker since 2023, and now we can develop our guideline in Thailand that they can checking each other. So this is what we do in Thailand, and I think it can adoption in your country as well. Next, please. Flow methodology is important in energy distribution. So we collaborate with energy stakeholder in Thailand, and because this is quite a lot of investment we cannot do today, so we have to plan it first. In addition, for hydrogen energy, they have a very special flow and very special technique to adopt for that. So we need time and also planning to develop methodology infrastructure to support the future energy. So at NIMT, next please, we have the airspeed measurement system. Next slide, please. That support the wind energy and also the important part for weather station. This is including of temperature measurement. Because I'm work in temperature, so I can say, I can calibrate from -190 until 1,500 for contact thermometry, and for 2,100 for 2,000 degrees Celsius for non-contact thermometry, but for contact is about 1,500 degrees Celsius. That serve for a lot of industry in Thailand to measurement high temperature accurately. Because even high temperature or low temperature, you lose a lot of energy on this, so this is more efficient. Okay, next please. My colleague Dr. Tada in photometry lab explained to me this work. So he developed and maintained national quality infrastructure for the PV system, like maintain the national measurement standardized for PV performance, solar simulator, and also pyranometer. This is according to IEC standard. In Thailand now, we try to lay down our scope that what we should do and what the other institution already do. This is very important because when you dealing with the PV solar, there is a lot of IEC standard, right? So we cannot invest all alone. If someone already did it best in your country, you just support it and do something else that they cannot do and you can do as an NMI. So we need to talk together to see that what we should do best to support your country. Each country have different landscape, yeah? Next, please. And this is how we develop our standard in Thailand. So we align methodology to the what energy policy in our country do, what the IEC standard adoption. We need to know the priority first. Even I would like to measure the temperature of hydrogen energy, but my country is still not doing yet. So we have to wait until we have to research first and then wait until we're ready and start to doing this to prepare this or do research on this, yeah? So now we're doing on smart grid first, doing PV solar first, and then the next step, what we do next. So, okay, next please. This is what I can show you that what our potential now for the energy measurement. It's not only electrical, only PV, but there are a lot of measurement infrastructure that need to prepare for sustainable energy measurement system. For example, in NIMT, I can say that for temperature and electricity, we have some CMC or what we call calibration and measurement capability that international recognize. What does it mean? It means that our customer can come from Malaysia, Indonesia, and calibration this parameter in NIMT, and you got a certificate that it can worldwide recognize according to IEC standard, according to ISO IEC 17025. And you can have a calibration certificate acceptance worldwide. While during waiting your country ready for support, you can seek another country to share this standard. This is what we do, and you can see our scope in BIPM website. We call the KCDB. At NIMT now we have 389 measurement capability that support physical and also chemical as well. Next, please. So this is what I would like to reckon through APMP Energy Efficiency Group. We can help to accelerate the capacity development. And because what we do joint project, we do some symposium like this to know that what you want, and I can link to the expert in country that already did it before and give you the advice and tell you what the best to you, what the instrument you should have to serve your capability. This is what the APMP can support DEC country. So this is can be developed to the intercomparison that you can have a CMC. Okay, and you can explore more about our activity knowledge sharing on the APMP website. So there are a lot what we do so far, nearly 10 years. We have a slide that talking wide range of energy measurement that you can adopt in the future. So renewable energy is not only about technology, it's about measurement and trust. I would like to address here in the next slide that methodology ensure every unit of clean energy and every ton of carbon dioxide reduction is real. So as APMP-EEFG chair, I would like to invite the international partners to continue building strong methodology for the renewable energy and clean energy. So let's make our future smart, green, and measurable. Thank you very much. ขอบคุณค่ะ
Thank you, Dr. Ojai, for the presentation, and please have a seat for the Q&A session. So please, if in the floor you will have any question, you can raise your hand, and then the mic will deliver by the committee. If there are any, okay, in the back, yeah, please. Would you please to say your name and then your institution or affiliation?
Yeah, thank you, Dr. Ong Chai, for your presentation. I have summarized at least 2 questions for you. And the first is, in your view, what is the single most critical metrology capability for Thailand or any ASEAN countries needs right now to support effectively the renewable energy? And then the second question is, for the countries in limited metrology infrastructure, what would be the most practical initial investment, whether it is training, human resources training, or equipment to build capability? Thank you.
Please directly to answer.
Okay, this is a good question, but I'm very proud of myself that in my field for renewable energy, I think I can serve all our customers because my field is in temperature, right? It's directly that how you how you want it. Maybe if in the future, is it like a future technique, photonics, or something that in the future, maybe NIMT still not go to that yet. But it's a general energy efficiencies, general renewable energy. I think for temperature, yeah, in my field, yeah, I think I can support most of that. Just tell me that what temperature you want, how you want it measured. You want a contact thermometry, non-contact thermometry. Just let you know. Just let me know. So no problem. So the next question is about the infrastructure, right? The question is about how to...
What is the most practical initial investment in human resources training or the equipment?
Yeah, this is why that we cannot randomly to do that. You need the expert to do that because when you get the calibration capability, it needs time, yeah? It needs time and effort to do this. You have to do the right thing, the right time, and on the need of your country first. We used to have establish some standard that no customer, so your boss will not happy. So you have to talk with your stakeholder first of what is the gap that they cannot do and would like NMI to do that. So, and then you come back to me, Oi Chai, can you find me the expert that can teach me to do this? This is a renewable energy. I will have a list of who I've been working with, and maybe we can have a workshop like this to sitting down and thinking that, oh, what is the best that you can do? And after that, when you got the measurement range, and the uncertainty that you need that suit for your country, and you can specify the instrument that you set and up to comparable to your budget or not, something like that. Because if you want high accuracy, you need more budget, right? So this is like we need to research on that first before start. If you buy things first and you cannot operate it, it just waste money, right? You need to operate the thing that you know that this is the good and this will be the future of your measurement traceability in your country. Yeah. So we can have a chat. I'm still here another 2 days if you come down and we can talk about this. Yeah. Thank you for question.
Thank you for explanation.
Okay, thank you for the interesting. Yeah, so the first time is knowledge, and then after that we need to collaborate, and then asking what is the need in the field, and then after that we can acting by the training or what the instrument we can buy. Yeah.
And you need to planning ahead. Yeah, in NIMT, if we want this instrument this year, we can't. We have to think first, and then you plan for the next 2 years to get the budget funding, yeah, to propose things, to find the budget. This is what we usually do in DEC country. I'm not sure that.
Yes.
But if you have a lot of money, so that's
it's
okay.
the same. Same situation. Yeah. Okay, Dr. Ochai, thank you very much for your presentation and question answer. Give applause to Dr. Ochai. Yeah. Yes, you can back to your chair. Yeah. Thank you very much. And then now we go to the last presenter. He is Dr. Arfan Sindu Tistomo. And now his position is the senior meteorologist at SNSU-BSN in the temperature and humidity laboratory. He earned his PhD in physics at Institut Teknologi Bandung, and his experience is as researcher and as meteorologist SNSU-BSN since 2006. Okay, sorry. And then actually, Dr. Arfan, he is doing activities and then participant in the regional comparison and also research in humidity and dew point temperature measurement. So today he will presenting the role of National Standardization Agency of Indonesia, SNSU-BSN, in supporting energy efficiency in Indonesia. Please, Mr. Arfan, to deliver the presentation.
Thank you for the opportunity. First of all, yang terhormat Pak Deputi, Pak Direktur SNSU-TK dan Bu Direktur MRB, mohon izin untuk memaparkan. Distinguished participants and ladies and gentlemen, please allow me to give my talk about role of SNSU-BSN in supporting energy efficiency in Indonesia. This discussion will cover introduction, and then solar power generation in Indonesia, quality infrastructure in Indonesia to support PV modules, role of SNSU-BSN, and the last conclusion. Okay. As one of the government institution, SNSU-BSN naturally follows and supports our government policy and also regulation. And this figure shows that electricity supply business plan for Indonesia from 2025 to 2034. As we see together that the blue line, which is the coal-based energy, is a dominant with almost more than 50%. But at the end of 2034, our government is planned to reduce this and increase the other, which is the renewable and new energy, or in this presentation I called NRE, the red color. Here, similar to the previous figure, but this table or it described is talk about the energy supply targets from 2025 to 2034. And we also see that the blue color, which is the coal-based energy, is planned to constant, but for the new and renewable energy is increasing. And if we look deeper on the new and renewable energy, we can see the plan for the composition of the new and renewable energy. there are three dominant energy, which are hydro energy or water energy, and geothermal energy, and the last is solar energy. So in this session, let's focus on the solar energy because it is also accordance with our activity lately. Okay. This slide shows the our government commitment to addressing the national energy needs and also for reducing the carbon emission. We can see here there are several solar energy plants that already installed and are being installed. For example, here we have a PLTS, mean solar power plant, Terapung Cirata in Purwakarta or West Java, which has 192 megawatt peak with the type of floating solar. This is the image, and the new power solar plant is PLTS Terapung Wadu in West Java also, and this is also floating solar, but just beginning in the beginning of this month. And others with the other type, ground mounted or rooftop. Sorry. Okay, so then the question is how to ensure that this power solar cell can give us best performance. So to address this, we have to know what is solar cell, solar power system. Here, the main components of solar power system. First, it consists of PV module, solar charge controller, battery, inverter, mounting structure, DC or AC cables, and connectors, monitoring system, for example, data logger or IoT. And from these items, we know that it is made by a manufacturer. So basically, manufacturers has a quality system to maintain or to ensure their quality. So now we talk about what is quality. So in Indonesia, we have a national quality infrastructure, as we can see in the left side of your site. The national quality system in Indonesia can be represented as a house, which has a roof as the product competitiveness and product quality assurance. And there are three pillars, which are standardization, testing, and accreditation, while metrology as the foundation. So in Indonesia, standardization, we have a BSN, Badan Standarisasi Nasional, or national standardization body, and also for the accreditation we have a CAN, Committee Accreditation National or National Accreditation Committee, and metrology we have SNSU-BSN. And for the PV module, we try to figure to more detail. For example, for the standardization, here, Ministry of Energy and Mineral Resources has initiated the application of quality standard for crystalline silicon PV by stipulated EMR regulation number 2-2021, and it implements one of globe standard documents, which is IEC 61215. And for the other pillars, which are testing and accreditation, we have in Indonesia 21 manufacturers and 2 accredited testing laboratories. This is the number of accreditation LP-069-IDN and LP-708-IDN. And for the metrology, we have SNSU-BSN, who has responsible for giving or providing traceability of the measurement in testing, and also for obtaining international recognition, as Dr. Ojai mentioned before. And similar to Thailand or NIMT Thailand, we have also some CMC. We have 2 CMC actually. One is accredited by Akan, and the other is registered to APMP-EEFG BAPM. And here actually we have around 388 scope accredited by Akan, and around 164 CMCs registered to APMP-EEFG BAPM. However, this current condition still does not enough to give a traceability to PV testing or PV measurement. For example here, according to the document IEC 6151, sorry, I forgot the number. According to the IEC 61215, there should be done heat test, which means the PV module is inserted to some chamber we call the climatic chamber, and the environment is to be set at 85 degrees C and 85% of relative humidity. If you calculate, it corresponds to the dew point temperature around 81. And by the traceability to the SI unit, it should be traceable to called dew point hygrometer. And here we have a chilled mirror hygrometer, and then the primary standard used here is called humidity generator. Unfortunately, our humidity generator only can be operated at 70 degrees C of dew point temperature. So we have a gap here. The requirement is 81, but we can only provide 70 degrees C. So what we did, we collaborate with some institution in Bandung, which is Institute Bandung Technology, or we call it ITB, through a doctoral program, and we made or we developed a new humidity generator we call the dew point generator, and it has already potential to cover to give our solution for this gap, but we also have the challenge by the transfer standard actually. So our chilled mirror hygrometer cannot be operated at above 50 degrees C because some problem. So this device already we put to the list to be fixed on next year. And the result already we published to the scientific journal in 2024. Okay, others for the role of SNSU-BSN is to provide traceability of IV measurement. Again, some of part or some of a range we already cover, but we also have a challenge in other range. For example, here the requirement start from 1 microvolt, but our condition cannot, our current condition cannot fulfill this requirement yet. And also for the current itself, we already have traceability for 100 microampere to 20 ampere, but the requirement again start from 10 microampere, and this range we cannot provide yet. Other activity that we already did is solar simulator measurement. Here we collaborate with the National Research and Innovation Agency, BRIN, Indonesia. Here our college do a solar simulator in chamber, and we already have a reference cell. It is traceable, but unfortunately we don't have local traceability, so the reference cell should be sent out and calibrated by other NMI. This picture taking at the BRIN, or Research and Innovation Agency of Indonesia, and this measurement under supervision of PTB Germany. And the last slide from me, this is a conclusion. So although SNSU-BSN has made and continues to make efforts to provide measurement traceability for instruments used in PV modules, there are still limitations. For example, the equipment and also human competence. So we are open to collaboration with various national or international partners to have a solution for this limitation. Thank you. That's all for me. And good afternoon.
Thank you very much, Dr. Arfan, for the presentation. And now we go to the Q&A session. If there are any questions from the floor, please to raise hand. Okay. Yeah.
Thank you for your explanation. My name is Helmi. I'm from Nation Research, Innovation and Technology. I will to ask you 3 questions, sir. First question is, currently there are 21 manufacturers with 1.6 gigawatt peak total capacity. Do we have sufficient local testing capability to serve this scale? And 2 accredited testing laboratory exists. Are there plans to expand or upgrade this to increase national capacity? And question number 3 is, what challenge do testing labs face in maintaining measurement traceability for high temperature or humidity condition? Thank you.
Thank you for the question. It's hard question.
Okay. You can try.
So yeah, I think with the policy of our government that's increasing the use of solar energy, I think there will be much more manufacturer in Indonesia. And I just read that in Indonesia we do not produce the solar cell, but we just assembly. So still there is a big opportunity for example, for entrepreneur to join and to invest in this field. And second, yeah, I think with the 2 testing laboratories that's not enough. I think to give us service for testing. So yeah, therefore we just starting to collaborate with PTB and other institution to have, for example, capacity building, how to measure solar simulator with good measurement, with good method, and also we inside SNSU-BSN also we try to develop some measurement. For example, our college here, they try to do automatization, how to scan homogeneity and stability of a PV module, for example, like that. So yeah, I think it's big effort for us, for Indonesia, to catch the status of other advanced country. And the last question is about temperature.
How to face maintaining measurement traceability for high temperature or humidity condition?
How to maintain?
How what challenges to face the high temperature or humidity condition?
Yeah. Okay. So as I said before in my slide, there is a measurement at 85 degrees C and 85% relative humidity. It means it has huge humidity. So the challenge is when we measure at huge, very high humidity, there is opportunity to have a condensation, and this condensation is our problem. It's make it can make measurement, our measurement stability. It can give us a false measurement. So yeah, to avoid that, we have to avoid condensation, which means we have to have, for example, pipeline with heater, and we heat the pipe above the dew point that we want to measure, and this is challenging. Okay.
Okay, yeah, thank you very much, Dr. Arfan, for the answer, and also thank you for the question. And then because we have limited time, so thank you very much, Dr. Arfan, and big applause for him. Okay, ladies and gentlemen, so all of the presenters was give their presentation. And then thank you very much for all our presenters for their excellence and provoking presentation, and to all participants for your active engagement and insightful question throughout the session. So before we move to the next agenda, let's take a moment to give a warm applause again for the speaker. Thank you very much. And then up to now, I will I will back the time and then stage to Mr. Reza, please.
Thank you, Mr. Aditya. And thank you to all our speakers for the contributions on the first session. Now we will present token of appreciation for all of our speakers. I would like to invite back to the stage all of our speakers for the first session, Mr. Q.T. Kim, Mr. Hugo Adams, Mrs. Oichai Ongrai, and also Mr. Arfan Sindutistomo. Please join me in the stage. Also, I would like to invite Mr. Gufron Zaid to the stage to hand the token of appreciation for our speakers in the first session. Okay. Okay, first we will give the token of appreciation. Please, Mr. Gufron. Yep, to Mr. Hugo first. Okay, please give a round of applause for Mr. Hugo. Okay, enough, okay. Okay, there's also a certificate for Mr. Hugo. Okay, thank you. And next for Mr. Q Tae Kim. Okay, thank you. Next, the certificate for Mr. Q Tae Kim. Okay, thank you. Next is for Mrs. Oichai Ongrai. Okay, and next the certificate. Okay, next is for Mr. Arfan. Also, I would like to invite Mr. Chris and also Mr. Xiong Liman to take picture together after this with the participant. Yes, so time is for taking pictures with Mr. Chris and also Mr. Xiong Liman. Okay, now taking pictures together with bareng-bareng Pak, izin taking pictures together. Okay, maybe we can move a little bit to the front of the stage. Move a little bit to the front of the stage. Yep, thank you. Okay. Okay. All right, thank you so much. Please be seated. Thank you. Once again, I would like to thanks to our speakers for the first session of the symposium. And now, before we have the lunch break, we will listen to a presentation from one of our sponsors for today. It is from AZEC Instruments Pte Ltd. To the representative of AZEC Instruments Pte Ltd, the stage is yours.
Yes. Selamat pagi, still pagi ya. Sorry, afternoon. Selamat datang. My name is Henry. I'm the so-called responsible person for AZ Instruments Singapore, also for PT AZ Indonesia. All right. So our business is also on temperature, like our friend from Thailand. Yeah, but we have to make our own money. We have to find our own money. It's different from her. She can go and get the budget from the government. right? So for a start, basically AZ instrument, we are very focused on temperature measurement. And as you can see, so same thing as what she said, but it's a bit different, same but different. So we can't manage what we cannot measure. It's very important, I think everybody should know in metrologies, right? This is what from Dr. Edward Deming. Right. So we talk about sustainability. Measurement is the basis of sustainability. In Singapore, we have a lot of standard and guidelines and measurements, wireless measurement, digitization measurement for process that use a lot of energy. So one of the example is chiller plant monitoring, because Singapore, like in Indonesia, we are in the tropical zone, right? Chiller plant aircon system use a lot of energy. In the building, in the factory, in the process plant, at least 50% of energy is used for cooling. And that's where the electricity is used, right? So instrumentation is part of the sustainability measurement and data analysis, performance evaluation, decision optimization, right? What we do in Singapore is that we actually push the boundary. We try to use more accurate sensor, more accurate measurement devices, and more accurate data logger so that we can actually get a better data so that we can optimize the equipment, right? So not just to measure and to manage, we need to measure accurately as what our doctor from Thailand, and to manage effectively, right? So we need data, we need better control, we need faster response sensor, we need calibration and maintenance, what we call M&V, measurement and verification. Okay, our company mission is basically every company have to have a dream, right? The dream is more like vision. So for us, we want to deliver precise measurement and sustainable solution for buildings, right? Contribute to the greener and more productive world. So this is our vision for the company. So every company, every establishment, organization should have a vision, right? Our mission is to provide value-added solution because we have to make money, right? So making money is part of our corporation, any corporation, right? And in Asia, customer in Asia by offering measurement and control instruments that consistently meet the requirement and regulatory approvals, right? So this is what we do, and that is, the best is that the regular approval is mandatory. Mandatory means that the industry have to use the standard, and the industry have to follow the standard. And of course, company also come with values. Values, we believe in ESG as what commonly done now, right? And global goals. Global means we do talk about sustainability, inclusiveness, green, right? We talk about saving the environment by doing what? By having Kaizen. Kaizen means basically, in Japanese term, always improve ourselves, okay? Embracing IoT, embracing AI technology, digitization, so that we can enhance efficiency and optimization operation and reduce costs across our company and for our customer. Okay, go back. So our company basically belongs to two subunits. One is providing sensor and instrument, and the other one is doing calibration services. And our services are also internationally recognized with ISO IEC 17025. We are very focused on temperature CMC. Our CMC in temperature is at 0 degrees plus is 0.0009 degrees Celsius, all right? And instrument side, we also believe in green mark and requirement for AirTax approval as well as energy saving. Like energy saving for green mark in Singapore is very important, right? So this is our company, sorry. This is our company team, our team together. So, and we also believe in green. So we have solar panel in our rooftop, all right? So these are the instruments that we are offering. You can see we have our own brand. We have calibration equipment from Isotech, from Chemo, from European country, from American, also from Japan. We make our own temperature sensors because we are very focused and we have the capability and competency to design and build sensors that's good for energy efficiency, also good for explosion-proof environmental, and also for special design requirement. And also we have weather stations and wireless monitoring solutions. These are some of the brands that we are representing. And so we are focused mainly on temperature now. Basically, we want to talk about ISOTEC. ISOTEC as one of the biggest or so-called most competent calibration equipment, temperature calibration equipment manufacturer from UK. And you can say better than or equivalent to Fluke. But in terms of technology and price, ISOTEC product is very competitive, right? So they have a full range of calibration equipment from primary to secondary to commercial and to in-house quality control requirement. So we have PRT, they have low temperature bath, they have portable bath, and also highly accurate measuring device like micro K for very, very accurate measurement of SPRT. So this is one of the special model that we want to highlight. So this is what we call a multi-function portable temperature bath. Basically, they have many functions here. You can use as a black body source to calibrate your infrared thermometer or thermal imager. You can calibrate also surface temperature. You also can use it as an ice bath. You can use it metal bath to calibrate your temperature sensors and thermometers, right? Thermocouple or RTD. And you also can use it for ITS fixed point cell operator. Means you can use it to maintain the ice bath, right, at 0.01 degrees Celsius. And most importantly, you can use as a steril liquid bath, right? So you can actually have a very high stability and uniformity at the same time. As you can see here at the point here, you can see the stability and the uniformity is very, very high when you use liquid bath options. All right. So this is my presentation. So if any question or any technical thing or even commercial question, our booth is just behind. You can drop by and have a chat with us. All right. Thank you very much.
Thank you to the representative of Isaac Instruments. Like he mentioned, if you have future questions, you can visit a booth of Isaac Instruments at behind of this area. And also you can visit our sponsors booth. We have PT Suko Vindo Persero and also PT Gencraft Labs. Ladies and gentlemen, now we will break for lunch and we will continue the symposium at 1:30 p.m. for the afternoon session. So once again, give a round of applause for all today. Thank you. And I'm Reza Aditya. I'm signing off from now and see you on the afternoon session. Wassalamualaikum warahmatullahi wabarakatuh. Silakan, Pak.
Kehidupan masyarakat dunia di era peralihan masih menggunakan peralatan sederhana dalam kesehariannya. Ilmu pengukuran atau metrologi sudah dikenal sejak zaman dahulu dengan menggunakan metode pengukuran sederhana dan menetapkan standar yang digunakan untuk memudahkan proses produksi barang, pembangunan infrastruktur, hingga memperlancar transaksi perdagangan. Revolusi industri yang berawal di Eropa membuat ilmu pengukuran terus dikembangkan oleh para ilmuwan. Bermula dari konvensi meter di Perancis, penelitian dan perkembangan meteorologi semakin cepat dan pengaruhnya menyebar ke seluruh penjuru dunia. Peranan meteorologi modern juga telah sampai di bumi pertiwi sejak zaman kolonial. Meteorologi digunakan untuk memperlancar kegiatan perdagangan rempah-rempah dan pembangunan infrastruktur seperti jalan raya, pembuatan rel kereta, dan sarana umum lainnya. Pasca kemerdekaan Indonesia, meteorologi terus mengiringi perjalanan pembangunan negara melalui peranan meteorologi.
Untuk teman-teman panitia, dimohon untuk merapat ke arah panggung untuk sesi foto bersama. Terima kasih. Sekali lagi untuk teman-teman panitia,
Kehidupan masyarakat dunia di era peralihan masih
izin untuk
menggunakan
merapat ke panggung untuk foto bersama. Terima kasih.
ASEC Group is a one-house solution provider for all your instrumentation and calibration needs. At ASEC Group, we understand that precise measurements are essential and critical for your business long-term success and sustainability. That's why we bring a comprehensive range of products and services covering diverse measurement and control aspects, including temperature, humidity, pressure, flow, level, air quality, and more. We have two distinct business units, ASEC Instruments and ISOLAB Singapore, each with a different focus. Our business operates through three well-established in-house brands to cater to different customer segments and applications. ASEC Sensing is our brand of custom-made high-accuracy temperature sensors, including green building applications, explosion-proof sensors, and thermowells to comply with industry standards and certifications. Blue Gizmo is our dedicated brand with a range of portable instrument and data acquisition systems trusted in food, HVAC, cold chain, and warehousing industries. Taisho focuses on process and control instrumentation with precision sensors that can be integrated with various systems. Isotech. We also provide calibration and testing services through our sister company, ISOLAB Singapore. ISOLAB is an ISO IEC 17025 accredited laboratory with dedicated expertise in calibrating a wide range of instruments, including temperature, humidity, pressure, electrical, stopwatches, timers, airflow, and sound level. ISOLAB can perform on-site calibration and temperature mapping for mega warehouse sizes, cold chain storage, and transportation facilities. Our in-house calibration capabilities at ISOLAB are actively upgraded to calibrate standard PRTs using ITS 90 fixed points. ISOLAB's capabilities for high-accuracy temperature measurements with incredibly low measurement uncertainties and capability is established to plus or minus 3 millikelvin, 0.003 degrees Celsius, for the temperature ranging from minus 196 degrees Celsius to 420 degrees Celsius. We can provide precision relative humidity measurements from 10% relative humidity to 95% relative humidity, with temperature range of minus 20 degrees Celsius up to 60 degrees Celsius, with an accuracy better than 1% relative humidity together with dew point capability. The ARM also has an impressive pressure calibration with capability ranges from minus 0.95 to 1,100 bar pressure range with an accuracy of 0.05 millibar. Our vision is to be the most reliable partner in caring for and providing accurate measurements and solutions. ASEC Group, measure accurately to manage effectively.
Berani menjadi yang pertama adalah kunci untuk membuka peluang yang tak terbatas. Peluang untuk menjelajahi horizon baru. Sejak tahun 1956, Sukovindo telah menjadi perusahaan testing, inspection, and certification terdepan di Indonesia. Memberikan pemastian dan rasa aman agar pelanggan dapat fokus pada bisnis. Setiap langkah adalah bagian dari perjalanan besar dalam menciptakan ekosistem perindustrian yang kompetitif dan berkelanjutan. Perjalanan itu menghantarkan kami hingga saat ini. Kami adalah perusahaan TIC terbesar dengan jaringan layanan terluas di Indonesia, mencakup semua tahapan proses bisnis, mulai dari tahap prainvestasi, pembangunan, produksi, hingga distribusi. Memberikan kepastian bagi sektor industri melalui jasa inspeksi, pengujian, sertifikasi, konsultansi, dan pelatihan. Memberikan kepastian bahwa setiap produk dan tahap proses bisnis memenuhi standar kualitas, kesehatan, keselamatan kerja, perlindungan lingkungan, serta peraturan yang berlaku di berbagai sektor industri. Mempertahankan integritas dan kompetensi dalam melayani, mendorong pertumbuhan pelanggan, dan memberikan rasa aman melalui sertifikasi produk. Setiap tantangan kami taklukkan sebagai komitmen dalam memberikan yang terbaik. Melangkah maju dan tanpa henti. Dunia yang terus berubah, demikian juga kami. Adaptif, menciptakan solusi untuk menjawab kebutuhan pasar yang terus berkembang. Inovatif, memperluas jangkauan dan dampak melalui transformasi operasional. Solutif, mendukung pelanggan untuk mencapai target keberlanjutan dan pertumbuhan usaha. Dedikatif, memberdayakan masyarakat, memperkuat ekonomi lokal, dan melestarikan lingkungan merupakan tanggung jawab sosial kami. Jaga integritas dan reputasi bisnis Anda, itulah yang kami lakukan. Sukovindo, assure your confidence.
Didirikan pada tahun 2006 sebagai penyedia solusi laboratorium terdepan di Indonesia. Sejak awal, kami berkomitmen menyediakan produk dan layanan berkualitas tinggi di bidang life science dan in vitro diagnostik. Untuk kebutuhan riset, akademisi, pengujian kualitas serta laboratorium klinis dan diagnostik, hingga ke skala produksi berbasis cell culture dan biofarmasi. Dengan pengalaman lebih dari 19 tahun, tim kami terdiri dari para profesional yang andal di bidangnya, baik di laboratorium riset maupun kebutuhan industri skala besar, mencakup bioteknologi, pertanian, perikanan, kedokteran hewan, keamanan pangan, farmasi, penemuan obat, serta diagnostik molekuler. Craft Labs telah dipercaya menjadi agen resmi berbagai merek global terkemuka, seperti Kiagen, Corning, Lonza, Binder, New England Biolabs, dan APMP. Brand-brand yang dikenal unggul di bidang life science dan biologi molekuler. Kami menyediakan instrumen laboratorium, reagen, serta consumables dengan standar mutu dan kontrol kualitas yang ketat. Untuk memastikan layanan prima, kami didukung oleh sertifikasi resmi seperti ISO 9001, ISO 37001, CDOB, CDAKB, serta tim aplikasi dan teknisi servis bersertifikat yang berpengalaman dan siap membantu pengguna di seluruh Indonesia. Dari instalasi, pelatihan hingga troubleshooting, kami hadir memberikan dukungan menyeluruh dan profesional. Di tengah pesatnya perkembangan teknologi life science dan molekuler biologi saat ini, Craft Labs terus berkomitmen untuk berinovasi, memperluas jaringan kemitraan dan secara aktif mendukung kemajuan sains serta peningkatan kualitas hidup masyarakat Indonesia. Craft Labs, empowering science, enabling progress.
Ladies and gentlemen, I invite you all to back to the seat because we will start the second session shortly. Thank you. Once again, I would like to invite all participants to back to the seat because we will start our second session shortly. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Welcome welcome back to the International Symposium of Energy Efficiency 2025. Can you give a round of applause for everyone today? Thank you. As I mentioned before, for this session, we will start our technical session, and this session will feature presentation from our great speakers, and they are Mr. M. Sultanul Aulia, Electrical Engineering Department, University of Indonesia, Mr. Diki Edwin Hindarto, Consultant and Expert of Energy Transition, Sustainability and Carbon Market, Indonesia, also Mr. Eric Agustian, Design System Manager at PT Surya Energi Indotama. Also, we have Mrs. Anissa Taradini, Researcher at National Research and Innovation Agency, or BRIN, Indonesia. And to lead this session, I kindly invite Mr. Aditya Ahmadi once again to serve as the session moderator. Please give a round of applause for Mr. Aditya Ahmadi.
Okay, thank you very much for the MC, for the in this afternoon, we have the second technical discussion. So in this opportunity, we change a little bit the scheme. I will invite first all the speaker, so not one by one, but I would like to invite all speaker. First is Mr. Sultanul Aulia from University of Indonesia. Please to join me in the stage. And then the second presenter is Mr. Diki Edwin Hindarto. Please join to the stage. And the third is Insinyur Eric Agustian, STMT dari PT Surya Energi Indotama. Please to join in the stage. And the last one, our speaker is Mrs. Anissa Taradini, MT from BRIN. Please to join us in the stage. Okay, thank you very much. Same like in our first session, so I will invite each of the presenter to deliver their speech, and then in the end of their speech, we will have Q&A. So one by one Q&A. Everyone will have speech, and then after the speech, we will have the Q&A. And for the first one, I will invite Mr. Muhammad Sultanul Aulia. Before his presentation, I will read the CV. Now his position is as electrical engineer in University of Indonesia, Department Electrical Engineering Department. He received his bachelor degree at electrical engineering at University of Indonesia, and then his experience is in working in smart renewable energy and storage device integrator for improving nanogrid resilience of grid mobile powerhouse charging session based on fuel cell and PV feasibility study with Petrosia, and then DC-DC converter development for DC microgrid solution in Coconut Island in collaboration with Hawaii Natural Energy Institute 2022. So for Mr. Muhammad Sultanul Aulia, please to give the speech.
Test. Okay, thank you for the opportunity to doing the speech. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
My name is Sultan Aulia, and you can call me Sultan. It is a honor to represent my supervisor in my university, Pak Dr. Eko Adi Setiawan, who cannot attend today because one of the reason. So I will talking about the renewable energy integration, which is the renewable energy, discussing about how the renewable energy evolving from the large-scale and centralized system and fossil-centered system to the decentralized system and low emission and also data-driven. So let's begin. Next. So before we're talking about the renewable energy integration, we must asking to ourselves, but looking forward, how the traditional energy system built. Actually, the traditional electricity grid was built in simple idea, I think. The electricity traditional grid, actually, it is built in the large scale to generate electricity, and it is developed to generate the electricity and transfer to the customer with the long transmission, distribution, and transmission. And the large traditional electricity generation, I think, have some disadvantage. Like we can see that long transmission and distribution, meaning that have a large energy losses. It is such 8 until 10% of energy losses from the generation until the customer side. But besides the disadvantage of the traditional electricity grid, we can see that the traditional electricity grid, we can see that any advantage from that. The stability, we can see also the power have transferred to our is we feel enough for the electricity, how we can use the electricity in every way, and so many are. So, with what is the limitation of the traditional electricity grid? We can see that it has many generations that need the fuel power system. It means it will emit many CO2 emissions. And we can see that in long transmission and distribution, it is very vulnerable to be sabotaged. When there is one who sabotages the transmission between generation until the customers, it will cut off the electricity from generation until customer entirely. So that electricity generation will be failed entirely. So also in the traditional power grid system, the customer will play as passive role. It means the customer will be customer always, and the producer will be always as the producers. The customer cannot be play as the producers. And in the early 20s, we can see that there's some transformation on our researchers to transforming the traditional electricity grid to the renewable energy integration. So actually there are three main key points, several points that will be boosting the renewable energy integration. The first one is technological innovations. We can see that innovation such as the solar PV, wind turbine, and the fuel cells, it is more efficient. We know that the solar PV already reduced the price almost 80% from the last 5 until 10 years. It makes more affordable to the users to buy. Test. For the battery storage system, and for the battery energy storage system, we can see that it can be play role as the complementary with the solar PV and the wind turbine, because we know that solar PV and wind turbine is intermittent. So the battery we can be compensated of the intermittency of that. So besides of that, the electric vehicle also playing role for transmitting us with the cleaner energy. The second one is environmental concerns, which means we know that the Paris Agreement and in 2015 already we already set the decarbonization targets, which means we can enhancing adoption of renewable energy resources for that. And the third one is government policies. For the government policy, the incentive and regulation can be adapted to the community. There are three incentives that can be adopted. The first one is feed-in tariff. The second one is net metering, and the third one is about the fiscal incentive. From that three factors, we believe that we know that 3 factors we can enhancing the renewable energy resources, and we know that we can see that the vision of renewable energy is not far away again. We can delivering the generation of electricity not from the big scale of the electricity generation, but we can do it in our home, in our vehicle, even in our yard. Next. So we're looking forward, and we must ask to ourselves, why do we so dependent of AC power? Historically, AC power is used to transmit the electricity over the long distance. We know that AC power is very good enough to transmit the power in the many kilometers. But this is from the industrial age. We know we can do generation now locally, not just only in the far away. Also, we can store energy in our home, in our industry, and also many industry can do the battery energy storage system on that. Digitalization can be done by ourselves, not far away from the rural area. And also, the one thing that make why we must transform the AC to DC is actually our device like handphone, television, air conditioner, or our laptop is actually natively by DC power, not AC power. It is true that
we input AC power to our handphone, but it is internally on the handphone or air conditioner. It is actually converting again from the AC to DC. From that conversion from AC to DC, there's some losses. It is about 15% losses. If we converting in large scale, it is big money. We already counting that. It is about 4 million US dollar per year. But with this several benefits of the DC powers, there are several also challenges from the DC power. The first one is limited of solar rooftop PV. We know that solar PV can reducing our bill of electricity, but if we compare the solar PV with the grid size or capacity, it is very small. It cannot maintain the big problem of the electricity in the grid. Yeah. So what is how to get the solution of this is the regulation from the regulator to implementing the solar PV in many area, so it can be minimizing the problem. Also, the second one is domination of the large investor. We know that the large investor is playing the vital role for the renewable energy. It is make the renewable energy cannot adapted properly with the community, so that the energy citizenship participation is very low. It is make the energy not democratized and also not used in many people. Next. So what we can do for that problem is bridging the gap between the real world and academic solutions by enhancing the energy landscape. The first one we develop DC-DC converter named DC on. This is DC-DC converter 3,000 kilowatt, 3,000 watt. That is applied to household appliances, which means it can be directly used to our laptop, to our air conditioner, to our handphone, and so on. Also, we already test on Hawaii Natural Energy Institute, and it already proved that DC power have superior efficiencies over the traditional AC system. But for the efficiency itself, it is still around 85 until 90%. We're still improving on that. And for the testing in the University of Indonesia, we test with the real condition, with the real load, and connected to the solar PV and battery, and then connected directly to the load, and we see the graphic of the efficiency and also the temperature. Next. This is what we have done in the Hawaii. So in Hawaii, actually used for solar boat charger. So the system is connected to the solar PV rooftop, and it's connected directly to the DC bus. And from that DC bus, connected also with the battery, and from that DC bus also connected to the DC on, and it is for charging solar boat. Next, and the testing result is pretty enough, yeah, pretty good enough. For the air conditioner, we can get the 4% efficiency compared to the AC system, and for the LED light, is achieving 5% efficiency improvement comparing to the AC system. And again, if we implementing this system in the large scale, we can save many energy for that. Imagine that 4% in one small city. We already reset on the New York City. It is about $400 million per year. Next. Also, we already get the approval for the standard national Indonesia SNI for the DC appliances within up to 300 volt DC for household appliances for enhancing our product safety and efficiency. It is our effort to get the compliances from the national standardization, also with the global efficiency standard. The second one is we also developing the power integrator EcoWall. So what is the EcoWall? It is the device that can connected to the battery energy storage system, also with the solar PV, and the specialization of this device is can be exported to the grid in the night, not only in the noon or afternoon. So if we looking forward for this idea, it is mean that we can stabilize the grid when the demand is high. We know that the demand of the grid is on the night. So when the night happen, it will reducing the voltage or frequency. So if we injecting the power to the grid in the night with this device, it can be stabilized with many devices. Yeah, not only EcoWall, only one unit, but we must to combine with many EcoWall, so to stabilize the frequency and voltage. Next. So we already test two devices of EcoWall A and B, and it is proven to be can be see that it can export in the night or evening to the grid. We tested in different area. The EcoWall A in UI, and for the EcoWall B in Cinere. The distance is about 14 kilometers. Next. So this is the result. The result of EcoWall A and EcoWall B. For the EcoWall A, it can be see that it can export the power during the peak demand, yeah, around 6 p.m. until 7 p.m. Also, for the EcoWall B can export power 1 kilowatt during that time also. So the benefit is can be benefit for two side, customer and producer. For the customer, they can sell the electricity in the high demand. If our nation already implementing the export-import. And for the grid provider, they have opportunities to stabilize their system to be more resilient. Next. So, for the conclusion is, we know that for the transformation of the renewable energy is must be collaborate with all stakeholders, from the customer, from the producers, and from the other side. For the customer side, we know that today we cannot generate the power, but the future, maybe the transformation itself can be customer will be generate, deliver, and also consume power at the same time. Meaning that customer itself will be as a prosumers, producers and customers. And then by transitioning of energy, we can achieve the efficiency gains and redefine energy management. And let us see new standard, explore new frontiers, transform of energy paradigm and sustainable future. Thank you.
Okay, thank you very much, Mr. Muhammad Sultan Aulia, for the presentation. So, if you have some question, please keep, because we will have in the end of all presenter give a speak, we will have Q&A. So the Q&A will be collected in the end of this session. So please keep the question, just write, and then you can raise the question in the end of this session. So I will move to the next presenter. The next presenter is Mr. Diki Edwin Hindarto. He is consultant and expert of energy transition, sustainability, and carbon market from Yayasan Mitra Hijau Indonesia. His education is Bachelor of Physics Engineering from Institute of Technology 10 November, Indonesia, and he experienced as Senior Advisor of Indonesia Joint Crediting Mechanism Secretariat and Head of Indonesian Joint Crediting Mechanism Secretariat, Head of Carbon Trade Mechanism Division of the National Council on Climate Change of Indonesia. And today he will present about Indonesia energy transition strategy toward achieving net zero emission. So to Mr. Diki, please, stage is yours.
Yeah, thank you very much. Assalamualaikum, selamat siang. Good afternoon, colleague. So, yeah, when I was invited by the BSN, I was very afraid because I don't know what to do and what to tell. And then my colleague here, Mr. Hekal, told me that I only need to explain what are my experiences in just energy transition. Yeah, so in this presentation, maybe it's very different with previous presentations because previous presentation, because in here, I'm not talking about the equipments. I'm not talking about all of the measurements, but I'm talking about the bigger parts of this, and it is the just energy transition. So in the just energy transition, just from justice, yeah. In just energy transition, what we have done in Indonesia is still preliminary, but we are trying now to do it properly by implement all of the good things, yeah. The implementation without harming any environment, any social, yeah. So, yeah, this next. So this is Indonesian zero emission strategy. So I don't know if it's already presented or not today, but this is how then we can reduce the emission and our target 2060, we will do the net zero emission. So you can see in here that the PLTU here is the coal power plant that will be reduced, and then we will implement the renewable energy. So I think the BSN have a very good parts in this because it's all using equipment of measurement and everything is in here. Next. And this is just last week. Established, launched by the President of Indonesia. This is our new target of the NDC, National Determined Contribution. So currently, we have what we call low projection that we must reduce 1.3 billion ton of CO2 until 2035, or then high will be in 1.4. So just launched last week. So don't ask these numbers. I'm not the one who make this. This is the government. Next. So then how then to achieve this? To achieve this, we will implement a lot of technology, clean technology, green technology to achieve this. So here, we do the energy management. We'll implement the geothermal, and then the nuclear, carbon capture and storage, gas, and then the wind and solar, also the green nitrogen, and then, yeah, this is our target, meaning that all of what we'll do will be full of technology, and technology means full of measurement, full of standards, because we must do it properly and in international standard. Yeah. Next. So why then we need to do the just energy transition? If we talk about just energy transition, it is a must thing to do if we implement the net zero emission implementation. Why? First, because we need then to keep social equity and economic inclusion. Yeah. And then energy access and affordability, and then community and stakeholder engagement, economic stability, global cooperation, fairness, and avoiding stranded assets and communities. So if we only do the transition without mentioning this, without doing this, so our energy transition will lose. Yeah. So the local people then will suffer, and then a lot of environment will damage. So we must have equilibrium, yeah, between social things, environment things, with technological things in here. This is just energy transition, justice for everybody when we do the transition. Why then I put in the cover the case of East Kalimantan and South Sumatra, because my NGO, Yayasan Mitra Hijau or Green Partner Foundation, currently we do implementation of just energy transition in these two provinces from 2023 until now. So we still ongoing. We try to do the not only energy transition, but people must be number one. Environment must be number one. Next. And this is the main challenge if we talk about the just energy transition implementation. First, a low level of policy coherence. Yeah. Still, you can imagine that even in Jakarta, there are only very limited people know about just energy transition. Even in the ministers, only some ministers know the concept of just energy transition. And then limited effective social dialogue process and platform for just energy transition. That's why in the 2 provinces, we develop what we call the dialogue between stakeholders. All of stakeholders sit together from the government, from the governor to the local people. They talk together on how to do the just energy transition. Then level of awareness relatively low, yeah. And then the skilling policies do not explicit mainstream green jobs and green skill. So we must push the green jobs, yeah. And then the non-tripartite stakeholders have limited involvement in here. That's why we are very keen to establish some of dialogue with women, youth, academician, non-coal, business sector, and everything in the 2 provinces, in South Sumatra and East Kalimantan. Next. And then this is what happened currently in the field. If we talk about the Indonesia, we are the second coal producers, exporter in the world. But we produce the coal, but 80% of the coal was exported. Yeah? But if you go to the province that produce the coal, so you will miss, because they are very dependent on the coal. First, if you talk about the East Kalimantan, for example, East Kalimantan currently their dependency on coal is 34%, and then South Kalimantan is 27% dependent on coal, and South Sumatra 17%. So if the coal price goes down, will be many jobless. Yeah. The economic also will go down. That's why we need to do just energy transition properly, yeah, smoothly. Yeah. The transition from coal-based economy to green economy is a must. But of course, we must do it carefully. Because if not, there are a lot of things. A lot of people will suffer. Next. Just for example, this is the Indonesia coal production and its price. So here, yeah, from 2009 to 2024, you can imagine that in the past 3 years, suddenly we have produced coal more than 2 times. And then the coal price suddenly very high. Because of what? Because of the war between the Ukraine and the Russia, and then the energy crisis in Europe push all of the coal price hike. So in here, yeah, in 2022, the coal price is only $80 per ton. Suddenly in 2022, in the same year, jump to 400, 5 times. You can imagine, everybody want to be coal miner. And then currently, go down. Yeah. Yeah, so you can imagine these provinces of the coal producers in Indonesia, they have this kind of condition all years. Next. That's why this is our strategy to do the just energy transition in this coal area. Coal-based energy system and coal-based dependent local economy. We push it by knowledge empowerment, social dialogue, policy change, transformational measures, and just energy transition to the low carbon climate resilience energy system and sustainable and just local economic and communities. Next. This is our principles. Benefit for employment and income are optimized. Yeah. Still, we need to still optimize the benefit for the employment and income. And the risk of job and income loss can be offset. Vulnerable groups are protected, involved in the process. Develop economic that produce lower emission and climate resilience and environmental quality increases. So our principle is no one left behind. Everybody must involve. Next. So this is the economic alternative in East Kalimantan and South Sumatra, the two provinces that we push to do the just energy transition as a pilot in Indonesia. So we are trying to push from the coal-based economy to the green economy, yeah, to the more sustainable economy. Again, if we do this, there will be a lot of measurement must be done. Next. And then this is how then to do, to finance the just energy transition. Yeah. Currently, if we talk about the climate finance model in Indonesia, we can divide like this. This is the carbon pricing, and the national budget, communities, private investment, FDI, and the blended finance in here. So if we implement the just energy transition, the system will be like this. This is a blend between the financial models or just one model or carbon pricing. So because the BSN want me also to talk about this, this is for the first time I try to mix between the just energy transition and the carbon market. So in the just energy transition, carbon market is one of alternative of the financing models. Yeah, only one of the alternative. Yeah, another is a national budget, of course, commodities, investment, private investment, and FDI. Next, and this is Indonesia implemented carbon pricing type. This is already implemented in Indonesia. We have done, developed the hundreds of, more than 200 of the CDM projects in Indonesia. Emission trading scheme, we already start this with more than 100 coal power generation in Indonesia. And then crediting scheme, we have VCS, CCM plan, FIFO, and CCW and everything. We also done the RE certificate, eligible energy certificate, and then result-based payment and carbon tax, yeah. And then we have new presidential decree, number 110, 2025, that has just released some previous policies that have obstructed the implementation of carbon pricing in Indonesia. So this is a very new presidential decree for the carbon pricing in Indonesia. And I think I convey all of the BSN colleagues in here to learn more for the carbon pricing, because your job will be in here. A lot of your job will be in the measurement of the carbon projects. Next, and this is Indonesia issued carbon credits from 2008 until now. This is status of the July 2025. So we have issued more than 100 million tons of the carbon credits and sell it to the world. Not only carbon credit, we also implement result-based payment, and then we also implement cap and trade. Next. This is some case study. Everything in here using measurement. This is a project, my project. From the study in here, I only use my project, my own project. First is my project in mangrove. We use all of the measurement and equipment for the mapping, for the methane capture and everything in here. So we in here we try to grow the mangrove in 11 provinces. Yeah, in 11 provinces. And then the longest is we have 1,300 kilometers from mangrove from Banda Aceh to Labuan Batu. This is successfully, we have developed it and successfully trade these carbon credits to the carbon market internationally. Next. And this is an ongoing project of Lekok Nangka Waste to Energy. And this is one of our projects, and how then to to reduce the waste while we also develop the energy. So again, that this technology was based, and here we're based on ISO 14064 and ISO 14065. Next. And we also, this is still ongoing project. This year will be finished. This is our 12 megawatt biomass power generation in Aceh Tamiang. I have about 61 projects under my supervision currently, and this is one of it. 12 megawatt biomass power generation that we use the M2 fruit branch, and then the waste from the palm oil to generate the electricity. Next. And this is the mining handle project that our project that developed by the project participant of Citra Multi Energy and Toyo Energy Farm. And again, in here, this is a part of the just energy transition. We trying to finance and then to push the private sectors to implement on the green technology. Next.
Mr. Diki, we have 3 minutes left.
And this will be my last slide, maybe. This is for the transportation. We implement from HSD from the gasoline to the gas. So again, a lot of technology currently are being implemented, are being tested, and everything will need measurement. Everything will need PSN touch. Next. And the conclusion, just energy transition is key to achieving Indonesia's second energy target. Just energy transition ensures that shifting from fossil fuel to renewable energy sources doesn't disproportionately harm vulnerable communities, workers, and regions dependent on traditional energy sectors. And the East Kalimantan and South Sumatra cases that implementing just energy transition will require the involvement and effort of all stakeholders. And then carbon pricing is one of the climate finance schemes that can speed up the implementation of net zero emission and just energy transition. And then if implemented well, carbon pricing will enhance the transparency, accountability, and sustainability of emission mitigation programs. And carbon pricing will also enhance the local and national tax incomes. So here I will stop here. And thank you very much. I'm very open to questions. Thank you very much.
Thank you very much, Mr. Diki Edwin Hindarto, for the presentation about the strategy toward achieving net zero emission. So again, if you have any question, please keep that question because we will have special Q&A session after all of the speakers deliver the presentation. Okay, we will move to the third one. Our speaker he is Engineer Eric Agustian. Now he is manager of Department Design System PT Surya Energy Indotama Indonesia. He received his bachelor degree from Electrical Engineering Institute Technology Bandung, and also master degree in the same Electrical Engineering Institute Technology Bandung, and he also received the Engineer in Electrical Engineering Program Institute Technology Bandung, and experience in Technology and Business Development Department and Project Management and After Sales Department. In this occasion, he will deliver about the PV manufacturer in Indonesia. So I think some question related with this one. So please, the Engineer Eric to give the presentation.
Good afternoon, everybody. Thank you for the opportunity that given to us to present today. For this opportunity, I want to present about PV manufacturer in Indonesia. Okay, next please. Okay, mungkin for the first session, I will talk about our company first. So I come from PT Surya Energi Indotama, which is established on December 6, 2009, 2007, and was acquired as a subsidiary of PT Land Industry on January 40, 2009. We are the pioneer of the EPC of renewable energy. So because we are one of the first EPC company in Indonesia that work in solar panel since 2009. Okay, next. Right now, we have many capabilities that link to solar plant. The first one and our basic business also, which is engineering, procurement, and construction or EPC. And also we have business of energy financing and investment in renewable energy. And we are also have capability of operation and maintenance for renewable energy, especially right now in solar power plant, and also in energy conservation, in retail solar power plant, and also in training for the solar power plant. Okay, next. Okay, and this is our portfolio, our product that we can build in solar power plant type. The first one is for rooftop solar, and also ground-mounted solar. And we are also can build solar powered EV charging station. Also micro hydro power plant. We also have one plant in Pasuruan, Jawa Timur, or East Java. And also we have product for solar power for telecommunication and the solar tree, and also solar street lighting. We also have the product. Okay, next. And this is our company experience because we have been in this business about from 2009. So we already built many sites, many solar plant in Indonesia. From Sabang to Merauke, from Rote to Miangas, we have already built a solar power plant. And until now, we have built around 146 megawatt peak solar power plant project all around in Indonesia. And you can see we also have many various type of solar power plant project, which is on-grid system, off-grid system, hybrid system, and also solar street light, and another kind of solar power plant project. Okay, next. And this is some of our portfolio that we have already built. Maybe you can see in the upper left, it is IPP of solar power plant on grid that located in Oil Puah Kupang, 5 megawatt peak, which is the first IPP, independent power producer, producing solar power plant in Indonesia. That before is owned by PT Land, our holding company, and recently will take over by us. And also we have Indonesia Penida Bali, 4.2 megawatt peak. This is, I think, the largest smart hybrid, smart grid in Indonesia, which hybriding the diesel generator and also solar power plant with 4.2 megawatt. And also the various kind of another power plant. And recently we also get the solar floating power plant in Barito, Kalimantan Selatan. Okay, next. So speaking of solar energy potential, Indonesia have large energy potential, which is from data we have potential about 3,000 gigawatt. And right now, the utilization is still tiny bit, just 1.5 gigawatt. So this is still large opportunity for the solar energy power plant to grow in Indonesia. Although that maybe from solar energy representative, maybe Indonesia not so high in irradiation, which is just 1.2, but it's enough for the economically scale and economical viable to build the solar power plant. And for the development plan in Indonesia, I think the most one that have to be developed like now is the solar rooftop, yeah. Because solar rooftop right now have maybe 1.5 gigawatt potential, and also I think the solar rooftop in Indonesia right now have firm regulation, have the firm regulation that control the solar rooftop. So many developer jump in solar rooftop business right now. And also the second is the big solar power plant, which is in the IPP side, but it's have some difficulty for the regulation, after the regulation, so not quite high with the solar rooftop. And also right now, many also have jumped in the floating solar, that in natural lake or dam, that we have some potential also, which is maybe it's some mistake is 89 megawatt, around 89 megawatt. Okay, next. And I think this is also have talked by another participant. So Indonesia have target to the net zero emission by 2060, yeah, or sooner, yeah. But for the realization of the solar power plant is just small, yeah. So right now in 2004, it's just about 700 megawatt of yearly total installed capacity in Indonesia. It's still far for catching up the net zero emission 2060. And right now for the development of solar power plant is many have we are like now have yearly quota allocation plan that managed by the PLN, which is in 2024 is about 900 megawatt, and every year it will grow the quota, and in 2028 it will about 1.5 gigawatt. And it is the good news that we have a quota, so we have the fixed market. That before we don't have quota, that it's a difficulty to get the regulation and get the permit. But right now with the quota, we can get the permit more easily for the solar power plant project. Okay, next. And talking about the PV module industry in Indonesia, right now the industry solar panel in Indonesia is existing just in the right side, yeah. So the existing right now is the module or panel assembler, the manufacturer, and also some industry that have the cell industry, which is like the Trina Arga that joint venture with Trina Solar in China. They have the cell industry. And the existing in Indonesia, we have 14 local manufacturers that join in the association or APMP, and few of another local manufacturer that not joined in APMP. So this is Petroleum Industry, our holding company, that is one of local manufacturer in the association. And why the industry of the upstream industry, for polysilicon, ingot, and wafer is not flourish in Indonesia? Because the investment is quite large right now, about 300 million USD, and also the market before it's not so certain for the market of solar power in Indonesia, and also the economic at scale. So because as you can see, the total capacity just 1.5 gigawatt for solar plant in Indonesia. It's small for the PV industry. We cannot grow with just 1.5 gigawatt installed capacity right now. Okay, next. And this is the example of our capability in solar module industry. So as I have speak, PTLN have manufacturer of solar pan, PV assembler like now. And we have capacity of 73 megawatt peak per year. And we also have the TKDN or local content, 47.5%. And I think the internal certificate that we have right now, we have IC 61225, for the test report, and also some of another IC like salt mist corrosion testing, PID testing, and ammonia corrosion testing. And I think it's interesting for the meteorological topic right now that we in PV industry needs this kind of measurement in Indonesia. And we have like some delay, maybe for certification of test report in for solar module, we need about 3 months for process. So it's quite long. So if he can improve the time for the test report and also for another test, I think it can make easier for our for the solar panel industry. And as you can see in here, this is our module capacity. Just we have capacity 100 up to 400 watt peak. I think for the current standard technology, our industry, PV module industry, more obsolete from China. I think China have 600 up to 700 watt peak module, and also the technology of the solar cell. We still use perch, but I think in current technology in China, they already using TOPCon and HGT technology. And this is our challenge in PV industry, because PV industry technology update is so very fast. So we cannot keep up with the current business in Indonesia. Okay, next. Okay, so this is one glimpse of trend technology in PV industry. As you can see, for the sum of factor, like the wafer size or the cell size, like you use full cell or half cell, and also bus bar trend, and also the module size, the growth is very fast. In 2021, you have the standard, and just few years to the future, the standard will change rapidly. So the PV module industry have to keep up fast with the technology. if you are not want to be obsolete. Okay, next. And this is maybe the history of the capacity of PV industry. So we, PT LAN and also PTC, we are one of pioneer also in solar PV industry in Indonesia. We have industry start from 1986 with just the assembly of solar home system. And we starting to assembling solar PV in 1998 with the 1997, sorry, with collaboration with Solarec Australia and BPPT or BRIN right now. So this is the first solar module factory in Indonesia in 1997. And we try to keep up with the current technology, but so up to 2080, we have the international certification for our module. So this is quite a long time of our industry timeline in here. Okay, next. Okay, next. Okay, the last thing I think I want to show about the challenge in PV industry, PV module industry development right now. So this is, I think, the negative cycle of PV module industry. The first one is we have, in Indonesia, we have the limited capacity of low economic of scale compared to another country like China or maybe right now the Vietnam or Thailand have also big economic scale of project right now. And also the second factor is the higher cost and price. So there is the low feasibility for the PV module. This is because in Indonesia, as I have explained that we just have the industry just for the cell module. So we don't have the industry for the upstream. So we cannot squeeze our cost of COGS, cost of goods supply, compared to the other country, especially China. And also for the regulation, right now for the project other than budget from the country, it's free. They don't need to mandate of using the local content solar panel. So the market for the solar panel with the local content is just small. And also for project financing in facility for EBT are still relatively high right now. In Indonesia, there is still doesn't have the special financing for the green renewable energy. And I think hopefully for the next year, many banking in Indonesia already have understanding for the solar, for the renewable, and can give some more easy of financial for the renewable energy project. Okay, so the last thing that I think we are required regulatory support from the government to encourage domestic production so that it can compete with imported product of solar panel in Indonesia. Okay, next. Okay, thank you. That's it, presentation for me. Thank you so much for the opportunity. Thank you.
Okay, give applause to Mr. Eric Agustian. Thank you very much for the presentation. And again, please, if you have any question for Mr. Eric Agustian, please keep the question, and then we will have a special Q&A session after the last presentation. Then okay, we move to the next presenter. Next presenter is Mrs. Anissa Taradini. She is a researcher at National Research and Innovation Agency, BRIN, Indonesia, in the Directorate General of New and Renewable Energy and Energy Conservation. He has received a master degree in Electrical Engineering, Institute of Technology 10 November, Indonesia, and also a master bachelor degree in Electrical Engineering in the same Institute of Technology 10 November, Indonesia. She has experience as supervisor at the PV Quality Testing Laboratory BRIN, and also Microgrid Research Group at BRIN, manager at Energy Research Laboratory, and also engineering staff of Electrical Technology Division at National Laboratory for Energy Conversion BPPT. So to Mrs. Anissa Taradini, now she will deliver the presentation about the advanced and challenging in photovoltaic testing in Indonesia. To Mrs. Anissa Taradini, please, it's yours, the stage.
Thank you, Pak. Good evening all. Thank you, BSN, for giving me the opportunity to be here with all the great speakers and all the great participants here to discuss what we did in our PV laboratory. I am Anissa. I am from Energy BRIN, National Research and Innovation Agency, or known as BRIN. It's a very exciting day, and this is our last session, I think. And I will talking about the advances and challenges in PV testing. Okay, let's start with the PV in Indonesia, based on the long-term electricity development plan issued by Indonesia State-Owned Power Utility, or PLN, until 2034. It is written that almost 70 gigawatts additional generation will be installed, and almost 70% of it are from renewable energy, and it's already planned that 17 gigawatts are come from solar power plants. Meanwhile, the status of Indonesia's solar power capacity, but this data is quite old, like in quarter 2, 2024, the installed capacity is only 700 megawatts. But this morning, with our first speaker from ESDM said that our installed solar capacity is 1 gigawatts, but still way more to go. And then, okay. As Pak Eric mentioned about the solar power plant that he already worked on the solar power plant, even though our solar power plant technology is getting mature, PV module performance and reliability are still concerned due to field failures and degradation. So that it may be caused by installation or by materials. Sorry, you can go back. Okay, like this, the misaligned cell connector or the local heating, the cell cracks, snell tracks happen in the PV field, the lamination, the discoloration or browning, the backsheet failure, and sometimes it happen with failure with the junction box or the cable from the PV modules. All the failure causing the lifetime of solar. It's okay, we can continue. All the failure causing the lifetime of the PV solar panel is decreasing almost half of its lifetime claimed by the PV manufacturers, and it affects the economic return on investment for solar power plants depends on the performance and lifespan of PV modules. So testing and standardization for PV modules are essential to prevent this to happen. National standard of Indonesia adopting IEC 61215 for crystalline silicon quality testing, a quality module, and it's regulated by ESDM by mandate number 2, year 2021. Okay. So this is the ecosystem of PV testing in Indonesia. It's regulated by ESDM, Ministry of Energy and Mineral Resources. They appoints and monitor the testing, both the testing laboratory and the certification body. Indonesia already have 3 laboratory PV testing laboratory. One is our lab, energy laboratory, and PT Qualis and PT Anindya. And then the certification body, we have several mentioned in the slide, and all of the tests are under 6, 12, 15 standard. Okay, this is I will tell you quickly brief about our BRIN organization structure. So all the laboratory that previously managed by LIPI, Batan, and BPPT are now managed by Directorate of Laboratory Management, and it organized under Deputy for Research and Innovation Structure. So if you already work with some of BRIN, it may be from the research organization. We work in the same field but with a different deputy. Okay, and this is our BRIN Energy Laboratory. We work, the PV lab are under Renewable Energy Laboratory. We have several testing service. One of it is PV module quality testing service. We also accredited by akan, and as a national laboratory, we work not only for testing service but also for research and supporting government regulation. This is our facility that we have in our lab, and I will give a brief explanation about the standard, about the test standard. So this is all this will be tested in these four tests: visual and electroluminescence, the flash, the sun simulator for IV curve. And then for electrical safety, we test the insulation and wet leakage, and the steady state sun simulator for stability test. I think this is similar with what NIM have in China. We have they also might have the PV lab complete test with for 6, 12, 15. So after we do this initial test, all the modules will be separated in 5 sequences, and then all the module will be tested again in IV curve and insulation and wet leakage test to see the power degradation, and is there any difference between the first initial state and the final state of the module after they are tested in hotspot or climatic chamber or outdoor test. Okay, and this is the other sequences. We have heating table, we have UV chamber, we have climatic chamber, hotspot test, outdoor test, mechanical load test, health test, and robustness test for testing the, MC4 and junction box of the module. Okay, these are several findings what we had in our lab. First is the power degradation. It is normally happen after all the tests that we did, like the outdoor test, aging test or breaking the module. It is normally happen, but it is the degradation are fine. If the degradation is more than 5%, then it considered that the module is failed. And this is the hotspot test. What we did in hotspot are we illuminate the module, and then we covered the cell one by one to simulate the shading of the module, and then we see what happened after 1 hour, after 5 hours, to see the possibility of the hotspot forming. And then normally the temperature is going around 100 degree, but for some cases the temperature is kept rising until more than 100 degree and makes a burn mark on the cell. If this happen in the field, the module will be burned, and it won't be good for all the systems. Okay. And this is another interesting thing we had in our labs, that we have the electroluminescence test. Not all the module will be break like this in our lab, but something bad happens, and we see how the module will look like in electroluminescence. The dark area shows that the module is shows the cell are dead cell, so it won't produce any current. And then in the third picture is the module after being used for 8 years. We can see a degradation. We can see a darker area in the edge of the cell. It shows a degradation of cell interconnection. And the last one, if it is the module that we test in the damp heat chamber. It shows a typical patterns that we see there that indicates some moisture ingress and humidity corrosion caused by the humid environment. Okay. Okay, as we see that before, I mentioned about the initial condition and the final condition of the PV. The IEC 61215 are meant to ensure that the PV module is reliable and could be installed in the field over a long term. So the test is important. It is important to perform the quality test and to ensure that the result is valid for PV lab regulators and consumers. The traceability is principal value to be present in our lab. The traceability is important to guarantee all the validity of the test result and for product certification to ensure that the test result, especially power, performance, and degradations, are reliable and comparable, and to assure consumers and regulators that the test results are valid. So we can compare the result from our lab to other labs that the results are good, and to support the laboratory accreditation. And since our lab is accredited by 17025, the traceability is a key point of the standard of the lab. It demonstrates the laboratory measurement system has metrological integrity that meets international standards. And then this is a little bit challenge in our lab. The uncertainty measurement can only be correctly calculated if all the measurement components has traceable documentation. Okay. this is what I mentioned before about the measurement uncertainty. Every lab measurement has an associated uncertainty that characterizes its reliability. Uncertainty analysis helps to identify areas of improvement in the measuring setup. The maximum power is the most important thing in our PV lab because it determines whether the module is good or is bad, or it has to repeat all the test process all over again. So the measurement uncertainty is specific to the measurement system and the tested devices, because it is specific, so we cannot take the formula from other lab to our lab on measurement uncertainty analysis. Many publications exist about the IV curve measurement uncertainty, but it is often treated as intellectual property, so we cannot just take the formula and put it in our lab. So the measurement uncertainty is specific to measuring testing setups, and different labs will have a different measurement uncertainty calculation. Even though it's a little bit challenging, but measurement uncertainty ensures that the credibility and comparability of PV performance data through continuous evaluation and discipline methodology.
Sorry, Ms. Anissa, we have 4 minutes left.
Okay. Okay, this is the practical challenge in PV testing lab. Pyric also mentioned before that the PV technology is very increasing. The wafer size increase, the PV size is also larger, so it requires big testing setups. And the more cell technology is, the cell technology is more efficient right now with technology like N-type, heterojunction, top-con, back contact. It requires, which has a very capacitive effect that requires longer flash time to reduce capacity effect in our sun simulator to measure the power. Okay. And other challenges are the readiness of our infrastructure. Our lab must be as upgraded and aligned with the 1730 standard for safety and reliability testing. The standard has a challenging for implementing the safety standard because the regulator or Indonesia is ESDM is waiting for the laboratory readiness. Meanwhile, the industry laboratory are waiting for the regulator to issue the standard formally. And I think BRIN, as the national research institution, should act to accelerate the standard development and serve as a leading laboratory providing both testing and research support. This is what we we have done in our lab. We improve infrastructure, calibration, and technical competencies, and strengthening the human resource and interagency coordination to ensure consistent and comparable result with PTB, SNSU-BSN, PT Qualis PV Laboratory, and PV Anindia Laboratory. And also with PTB through strengthening quality infrastructure for PV sector project has supported us, providing support in ensuring the quality of PV test labs, such as training through expert, conducting assessment, consultation, and technical discussion. We can see on the picture on the right above, Anindia has a very pretty big chamber for a big module, and the other picture on the left, PT Qualis have a sun simulator that possible for them to flash bifacial module. Okay. And this is our recent project with SNSU-BSN and PTB. This is we classify our sun simulator with spectral match, irradiance uniformity, and temporal stability. This is what we have. The irradiance uniformity testing that we previously have done. So the red one means the lesser irradiance received by the area. But even though this is not so uniform based on the picture, but the number is quite good. But I think it's still confidential to give you the numbers. Okay. Okay. So the conclusion are a test laboratory is essential to ensure that market products meet the required quality and safety standards. Product testing helps increase consumer confidence and reduce the risk of product failure. It also ensures compliance with regulatory requirements. And traceability is crucial in a PV laboratory as it allows every test, material, and result to be accurately tracked and verified, ensuring reliability and accountability. Okay, thank you. I think that's all from me. I'll give it back to the moderator.
Okay, thank you very much. Give applause to Mrs. Anissa for his excellent presentation. And now we in the Q&A session. So if you have any question for all presenter, so please raise your hand. If you have any question, please raise your hand. Yeah, please.
Hello, I want to know how do you calibrate the maximum power? Use standard solar cell or standard PV module?
I think this question for Mrs. Adini, please, to answer directly.
So when I see your presentation and your laboratory, I think our lab still have a lot of things to do compared to your lab. So how we calibrate our power measurement is we have this cell gain. It's called the cell gain. I think our sun simulator is the same. Is it PASAN sun simulator? The sun simulator? Yeah, because I see it
I know simulator.
Yeah.
But you used to the standard. Maybe you use PV module. Maybe you used WPVS solar cell.
Oh, yeah.
Yes. Just use solar cell, you cannot get the value of the PV module power. So I don't know. Of course, maybe you only need to the deviation of the PV module. You don't need no absolute value of the PV module. But I think maybe you need to transfer to BSN, maybe the other country. Okay.
So you calibrate your standard abroad? Or?
So we only calibrate the, we call it golden module. So every single day we do the reference measurement with that golden module. We didn't calibrate sorry, I'm mistaken. We calibrate the E-load card on the DUT.
Okay.
We calibrate the E-card and also we calibrate the golden module.
So it's only a relative value, not absolute value.
So its calibration is in relative, not absolute calibration?
Yeah.
Okay. Can you repeat the question?
I mean, the calibration is in relative or absolute measurement?
I don't think I understand what the mean of
relative or
relative calibration.
I also the same. Maybe you can discuss in the
Yes.
after this.
Maybe we can discuss tomorrow.
Yes, yes.
We
I think
visit your laboratory. Yeah.
Yes, yes, yes. Okay. Because doctors concerned about the traceability and then how you calibrate your standard to make it traceable. Yeah.
Oh, okay.
So maybe you can discuss after the session.
Yeah, I will talk to you later.
Okay, thank you.
About this.
Yeah, thank you very much. Is there any question? Please, yeah, in the back, right.
Thank you. My name is Dedi. I'm from PT Anindia Certification and Testing. Yeah, we have a PV module laboratory, and then the process is for accreditation and waiting for the appointment of from Ministry of Energy. My question for Ms. Anissa. Yeah. As your explanation, the measurement of uncertainty is important matter. So my question is, there is any reference that regulated the acceptable limit of uncertainty value? So the laboratory can confident that the uncertainty value that have been calculated is correct. Thank you.
Okay, so for also Mrs. Anissa, you can answer directly.
Okay. The limit, the question is about the limit of the uncertainty of the power measurement, right? So as long as I discuss with the PTB expert, is I think it's 2%, but without the K factor. Yeah. So it is the U, the without the K equals to 2. Yeah, I think that's what we had before with our discussion with PTB expert. Thank you.
Okay, is the answer was answered? It is. If it is okay, so we can move to another question. Yeah, Mr. Hugo, please.
Thanks everyone for those talks. My question's for the first presenter. I was wondering, you talked about that DC to DC converter that you've made, 3 kilowatts, I think you said. Obviously, when you go up and up in power, which is what you're going to have to do if you go in the direction of high voltage DC transmission, these topologies change, which will affect your results. So is there plans to do similar tests for higher power DC to DC converters in your lab?
Okay, please.
Yes, actually, we test in our lab with the DC-DC converter 3 kilowatts. Yeah, 3 kilowatts, and then it connected to the PLN, to the grid, and yeah, in the night we try to exporting to the grid 3 kilowatts, and actually this why we can export the power to the grid in the night, because the DC-DC converter is acting as the PV, the solar PV. So the DC-DC converter is connected to the inverter first, and then inverter convert to the AC power, and then synchronize with the grid. Yeah.
Yeah, but is there any plans to up that power at all? Make it maybe 5 kilowatts, 10 kilowatts, something that industry might use or residential homes might use?
Yeah, currently we only 3 kilowatts, but we are still developing within 5 kilowatts.
Yeah, cool, thanks.
Okay, thank you very much, Mr. Auliar, for the answer. So, please, is there any question? Mr. Arfan? Yeah.
I would like to ask for the third presenter. I'm sorry, I forgot the name.
The third one?
Yes.
Yeah. Mr. Eric.
Mr. Eric. No,
Yeah?
in the middle.
Yeah.
Oh, Mr. Dicky.
Sorry, Mr.
Dicky.
Dicky, okay.
Yeah.
Okay, Mr. Dicky, very interesting presentation. So you said that the strategy for the society not to give a shock. You said that the strategy is push to work to the green activities, right? And try to keep the coal still in the hole. Yeah. But this remind me that many of coal mining is belong to our government official. How do you deal with it? I mean, I think there must be rejection or some challenging from even from our official. Thank you.
Okay, please, Mr. Dicky.
Okay. Yeah. Thank you very much. Yes, we call it. This is unlucky for us because what 6 or 7 of our ministers are correlated with the coal. But like it or not, the coal will be reduced. The coal production and the coal demand will reduce because 80% of our coal production goes to the export. And currently, the export demand is slowing down. Because of what? Because if we talk about the climate change, all countries in the world, including USA, actually know that this is a very serious condition and very serious thing that need to be translated into action. So the Just Energy Transition said that if we talk about this, like it or not, the demand will reduce. And the government itself, this current government are also very strong and very strict for the early retirement of the coal power generation, pensiun dini or early retirement. So some of the coal power plant will be closed. And we have also moratorium. We stop all the new coal power development. So this make, like it or not, if you have coal shares, so yeah, it will be also going down. But yeah, you still have time, maybe until 2040. You can still have a party. Before it is the party, yeah, all of the party will finish. Right? Not no party will last forever, including the coal mines. And second, in the Just Energy Transition, we not only talk with the society, and we not only talk with the local people, local government, academician, but also we talk also with the coal producers, yeah, the coal mines, and then the coal workers, and also the coal workers association. So if the coal will reduce, the one who will suffer a lot, not only the society, but also the coal mines and the coal workers. What happened to the coal workers that currently more than 1 million in Indonesia? So if the coal will be stopped, what happened to them? So we also will, we also talk with them. We give some trainings to them, some trainings to do the new jobs, yeah. And the coal company itself, every coal company now are starting doing the green projects. So don't be surprised if you heard Adaro or maybe KPC, yeah, have their green projects in Indonesia. They have. Or if you have heard the infamous Haji Isam, currently also have his own green projects in Indonesia. So like it or not, brown must turn to green. Yeah, and this I think again we need a very good measurement in here. We need good engineers, good system like the BSN, how then to measure, how then to do the MRV, so everything will be transparent and can be traceable. Thank you.
Okay, thank you very much, Mr. Diki, for the answer. So, if there are any question, I will still open the question. One more, maybe. If no, I have question to Mr. Eric. Yeah. Very interesting about the whole industry for photovoltaic in Indonesia, based on your experience. And you say that today the upstream industry is very hard to flourishing in Indonesia because we only have 1 gigawatt here. So what is the expectation? How gigawatt we need? And then it is more economically to flourishing the upstream industry. Can you explain about this one?
Okay, thank you for the question. Maybe the market capacity is just one reason, one reason of some of reason that why the upstream industry is not flourishing. And if we talk about the market, I think if we want to flourish the upstream industry in Indonesia, I think it's have to offer than 10 gigawatt a year for the project, or maybe we can compete and capture the export market. But for the export market, we have to compete with China. So that's the big battle if we want to exporting. It's the first one. And also maybe the second reason, second main reason for the upstream is I think the cost of power supply, because the upstream industry is need high power for industry to grow, and the power have to be cheap because the competition is so high. So we have to supply the upstream industry with cheap power supply. I think that's two main reasons for the upstream industry to flourish in Indonesia.
I think it's still very challenging, for Indonesia, but hopefully it's getting better and better in next future. So I think this is the end of the discussion for the last technical discussion session. Thank you very much for all the speaker, and please give applause to all of them. And then this is very beneficial for us. Thank you very much for the question for the floor. And then hopefully some days we can gathering again in this occasion. Thank you very much. And then I will give the stage to MC, Mr. Reja, please. Thank you very much.
Thank you, Mr. Aditya, and also thank you for all speakers. I would like you guys to still stay on the stage. Now we will give the present tokens of appreciation for the speakers. So I would like to invite Mrs. Dias-Tiarini to the stage to hand the token of appreciation for the speakers in the second session. Boleh izin untuk berdiri di depan. Terima kasih. Okay. First one is for Mr. Amsutanul Aulia. Okay. Take a picture first. Yeah, and the next is the certificate. Next is for Mr. Diki Edwin Hindarto. Okay, thank you, and also the certificate. Okay, and next is for Mr. Eric Agustian. Okay, next is for Mrs. Anissa Taradini. Oh, sorry, the certificate first, sorry. Okay, thank you. And next is for Mrs. Anissa Taradini. Yeah, next is the certificate. Also, after this, I would like to invite Mr. Chris, Mrs. Oichai, Mr. Gufron, and Mr. Xiong Limin to the stage to take a picture together with the presenter of the second session. Okay, please, to take a picture. Yep, Mr. Xiong Limin, Mr. Gufron, Mr. Chris, and Mrs. Oichai. Okay, okay, slightly to the left, please. Okay, thank you. Is it good? Okay. 1, 2, cheers. Okay, thank you. Thank you very much. Please be seated. So next we will have a group photo for the international participants. So I invite all the international participants to the committee. Will we take pictures on the stage or in front of the stage? Is it on the stage? Yep, is it on the stage to all the international participants and also international speakers? Once again, I invite you to go to the stage, please. And also, I would like to invite Mr. Chris. Yep, to have the pictures, Mr. Chris, with the international participants and also international speakers. And also, Mr. Chris, is it Mr. Helmi? Yeah, is it Mr. Helmi still with us? Mr. Chris is asking for Mr. Helmi to join to take the picture, please. Yep. Okay, let's take a picture together. 1, 2, cheers. Okay, maybe we can have this symbol as a spirit. So yeah, we can fist our hands, yep, together. So this is like to show our spirit. I know it's already late in the afternoon, but yep. Okay. Thank you so much. Please be seated. Thank you so much. Once again, I would like to thank you to all of our speakers from the first session and also for the second session. Ladies and gentlemen, as we come to the end of today's program, I would like to express our heartfelt thanks to all speakers, participants, and partners for their active participation and contribution in this important international symposium. And also, our sincere gratitude goes to our sponsors, ASIC Instruments PT Ltd, PT Sukovindo Persero, and PT Gencraft Labs, for their generous support in making the symposium a success. May today's discussion and collaboration inspire impactful actions for sustainable energy across Asia-Pacific region and beyond. Before I close this symposium, I would like to share some information. The materials and certificate can be downloaded from the link that provided in the QR code. So you can scan the QR code, or also maybe you can type the link. And also, the second and third days of the BMN program will be held at SNSU. So for those who are joining the second and third days of BMN, the event will be held at SNSU building. Is it consisting of workshops and also scientific presentations? And the second day of the EEFG program will include a technical visit to the PV manufacturer and testing laboratory. So for those who are joining tomorrow's visit, the participant expected to be gathered in the hotel lobby at 7:30 a.m. Once again, for the participant who are joining tomorrow's visit, the participants expected to gather in the hotel lobby at 7:30 a.m. Finally, on the behalf of APMP-EEFG and SNSU-BSN, I would like to say thank you for joining us today. And also, I apologize if there were any lacks or errors in today's symposium. I'm Reza Aditya, your Master of Ceremony. Wishing you have a wonderful evening and see you again at future collaboration. Wassalamualaikum warahmatullahi wabarakatuh. Thank you. Yes, for all the participants, the committee already prepared a coffee break outside the area, so you can enjoy the refreshment. Thank you.